on this view, the sentence 2 is prime, or let's say there are prime numbers, is literally false. What is a number 2? Is that something that, if we build a big enough particle accelerator, we'll get to discover? I mean, the idea is like there has to be something wrong with the view that the final theory of the world involves a whole bunch of, again, using diminutive language, Platoplasm up in Plato's heaven, along with the causal world with which we interact. Okay, but that raises a serious problem, which is, okay, give us the theory then that doesn't use the Platoplasm.
Welcome, everyone, to the Cartesian Cafe. I am your host, Tim Nguyen. Today, we're very lucky to have Justin Clarke-Doane here with us. Justin is a professor at Columbia University whose interests span metaethics, epistemology, and the philosophy of logic and mathematics. Justin is also the author of 2 books, Morality and Mathematics, and Mathematics and Metaphilosophy. Welcome, Justin. How are you doing today?
Thanks, Tim. I'm doing okay. How are you doing?
Great. Yeah. Great to have you here. Today, we're going to be talking about 2 topics which kind of rarely are discussed together, namely morality and mathematics, a book which you wrote by the very same name. And I think there's an obvious reason why those 2 topics aren't usually discussed together, which is that they're very different domains. Morality is about human action and affairs. Mathematics is grounded in logic and abstract reasoning, and so it could hardly care less about what human beings are up to. But I think there's also sort of a sociological reason, which is that the people who are experts in morality and mathematics don't usually overlap. And so you're an exception in this regard, in that you've thought about morality and mathematics deeply at a philosophical level. So can you start off by telling us a little bit about your book and why you came to write it?
Yeah, sure. The original motive behind the book was thinking about a word that is probably overused, but it won't be foreign, I think, to your listeners: naturalism. The idea that in some sense there's only the world delivered by science, and what does that belief entail? And a famous problem that preoccupied a lot of philosophers in the 20th century, but it hasn't gone away, is that science, empirical science, seems to be up to its ears in math. And what is math? What are numbers, and what are metric tensors, and what are Hilbert spaces, and whatever. And so there's a good case to be made that whatever naturalism is, it entails mathematical realism. So if you think there's an independent fact about the standard model of particle physics, or general relativity, or ideally, some unification of the two, that in quantum theory of gravity, it seems like whatever it's going to be up to its ears in math. It doesn't seem like it makes say, I'm a realist about this theory, and then you write a bunch of math on the chalkboard and you say minus the math, So it seems like whatever naturalism entails, it's going to entail mathematical realism. Now, it's widely thought that it won't entail realism about value. Value is like the paragon of something that's subjective. It's, in the eye of the beholder. In math, and in science, you can settle things, or in ethics, we just argue endlessly. So, the natural thought is that that one can be a naturalist and not a realist about value. That's a very common view. And I came to think more and more about the cases or the arguments for and against moral realism and mathematical realism. And I came to think more and more that actually this is a kind of incoherent combination of positions, because the arguments for and against mathematical realism are, with an important exception, which I'm sure we'll talk about, mirrored in the moral case. So that if you're a mathematical realist, which seems to be entailed by naturalism, as for the reason I just mentioned, then you need to be a moral realist too. And yet that seems nuts. I mean, it seems like I'm in the natural world and not think there's a pie in the sky answer to the question of how I ought to live my life. So that's I only decided to write the book when it sort of took a step further and became a kind of positive overall picture, rather than just this kind of critical, companions and guilt point. But that's how I started writing on the issue and thinking about the issue seriously.
Justin, I think that's actually quite surprising, and that's actually why I brought you on to have this discussion, because indeed, I think most scientists, as you state, myself included, are at least kind of unreflectingly at least, mathematical realist and moral anti-realist. And we'll get into those terms soon. But in the sense of, we think of math and science as being rock solid and absolute, and morality as being kind of mushy and diluted by human affairs and preferences, right? And sort of therefore not absolute in any global sense, given that we're just this, living on a tiny speck of dust in this vast cosmos, right? So I think that's sort of like the default view, more or less. And your book is basically challenging that. And yeah, so I think it's very interesting to go into that. As usual, I like to start out by writing an outline just to, since of course our conversations are quite in depth, it'd be good to kind of give a roadmap of what we're going to talk about. I think given how a technical philosophy can be, I think we could spend kind of the first bulk of our conversation kind of giving an overview of the basic positions on the table, basically mathematical realism and anti-realism and their moral counterparts. And then we could spend the latter half or fraction of the discussion on basically your contribution through your books and kind of outlining the various chapters and the positions that you take. And we'll see how far we get, but I think that should be a very substantive discussion.
Sounds good. That's great. Yeah.
Okay, great. Let's go to the whiteboard then, and I'll go ahead and write out what I think will be a good outline. So I think kind of, as I said, the first part, we'll just give the background on mathematical and moral, realism or its counterpart, anti-realism. So basically is mathematics and morality real or not real in some sense that we'll get into. That's sort of like the heart of the discussion. So that will be sort of the background. And then the next few bullet points, I'll just kind of summarize basically the chapters in your book by a few kind of high-level concepts, which I think will kind of, at least hopefully, whet the appetite of the viewer in terms of why this topic is interesting. So it turns out that in the second chapter of your books, I'll also number this in the sort of chapter order, you get into this feature, which I think is certainly not very appreciated or thought about by mathematicians, which is that there's actually a lot of disagreement and uncertainty in mathematics. Well, at the foundational level, at least, which is not what practicing mathematicians typically think about, right? We prove theorems about concrete things like numbers and geometries, but very few mathematicians think about the axioms of set theory, the continuum hypothesis. Those are very niche topics. But if you sort of really dig in, there's not as much unanimity as one might expect. And so that's kind of maybe a good place to start in terms of thinking about the ambiguities of morality and juxtaposing that with mathematics, right? So that's sort of what you do in that chapter. And so that's, I think, and that's also, I think, a good place to start, because sort of, for mathematicians like me, it's good to kind of maybe remind ourselves and keep us maybe a little bit more humble, if nothing else. And the third chapter, I'll just summarize it as empirical science and justification. And we'll unpack these as we go in. I just don't want to get too deep into the weeds, but basically here, essentially we have topics like mathematics and morality, and they play a role in explanations of the world, right? And you alluded to that already at the beginning. Mathematics is all over the place in physics, and we use morality to explain human behavior and sort of the relationship between our explanations and whatever credence they give to their status as real things, right? So that's sort of the topic there in chapter 3, right? Feel free to interrupt if I sort of botched anything, but I'm just sort of going through the overview here. And then chapter 4, you talk about basically the relationship between evolutionary arguments and realism, right? Sort of, I guess it's kind of intuitive that our morality developed through evolutionary means somehow, because we have to interact with other humans, and so our morals are obviously informed by that. I guess maybe mathematics is maybe a little more non-standard to think about, but I guess there's also an intuitive argument that, if you don't understand that 2 lions plus 2 lions is 4 lions, that might be problematic for your survival. So basically that chapter is sort of exploring the relationship between these kinds of evolutionary arguments and again, the realism of mathematics and morality, right?
Yeah, and I mean, just more generally, how we would know independent facts about math or ethics, and whether that problem's harder to solve in one case than the other.
Sure. Yep. Okay. Yeah. And so that's the content of that chapter. And that actually leads us into the topic of the 5th chapter, which is the so-called reliability challenge, right? Which is, to kind of summarize, is that, if we're going to say things like numbers are real or morals are real, those are abstract things that, don't causally interact with this necessarily. And so how do we, as these very limited human beings, come to know these things as being real, given that they're abstract, right? Well, what does that actually even mean, right? Yeah. Okay. So that's the reliability challenge. I guess maybe that's like Plato's cave, like 2.0 in some sense, not that I think about it, right?
Yeah,
at a high level.
Yeah.
Okay, great. Yeah, and finally, there's this issue of mathematical versus moral pluralism. So, I guess we're all familiar with the fact that mathematicians can work with different axiom systems, right? Like there's Euclidean geometry where you keep the parallel postulate, and there are non-Euclidean geometries where you reject that postulate. And likewise, moral pluralism is even more obvious because there are many different moral systems, and sort of the final chapter is sort of comparing and contrasting those two situations and how they're, I guess in your case, very, very dissimilar, right?
That's right.
Yeah. Okay. I did most of the talking here, but is there anything you want to add to this outline, or should we just dive right into it? Or do you want to maybe give the high level, like, I don't know, conclusion, or should we save that for maybe later?
Yeah, I mean, we can do that later, except just to say that, the conclusion then asks, okay, so we've looked at ethics and math. Is there something it can teach us more generally about areas of philosophical interest, including things like logic or counterfactual reasoning or other kinds of norms? And the answer is supposed to be yes. So there's a further advanced of more generality than just ethics and math. But yeah.
Yeah, and I guess I should also add, I think kind of hopefully with this outline, it becomes kind of, I think for me, the surprising thing about having thought about these topics now, enabled by our preparing for your conversation, is that there's a lot more kind of commonality and overlap in sort of the ways of thinking about these subjects than one might naively think. In terms of, you might naively think, again, as I sort of said at the beginning, math is about logic and abstraction, morality is about human affairs, and they just don't overlap. But sort of this outline in our conversation sort of dispel that belief, right?
Yeah, well, I mean, we'll see, but I mean, that's my view.
Yeah, great. Okay, awesome. So let's just go ahead and get into it. So let's go to the next slide. And yeah, Justin, why don't you take it away and give us kind of an overview of mathematics, morality, realism, anti-realism, etc.
Yeah, okay, great. So maybe I should just start with, what is mathematical realism intuitively? And mathematical realism is just the idea that there are independent mathematical facts that we can hope to discover, kind of like the view that kind of like scientific realism is the view that there's independent scientific facts that we can hope to discover. So math on this view, according to mathematical realism, is in the business of discovery rather than invention or creation. So on this view, when Euclid proved that there are infinitely many prime numbers, he discovered something that would have been the case whether or not anyone had proved it. It's something that we could have been wrong about. In that sense, it's just like any other scientific question. Now, it's a little more subtle than that. And the reason is something you already alluded to when you mentioned that we're all familiar with different axioms in math. And so there's one kind of view that is kind of uncontroversial in this context. There's a whole other context that we could talk about, which is the philosophy of logic, where these things become controversial. But one question is, are there facts about what follows from some selected axioms that are independent of us? So do we get to make up the facts about what follows from what? that is not a special issue for math, right? I mean, you can ask that about anything. Every area you can regiment some principles. You can ask them what follows from those principles. You could do about culinary facts, like what's tasty. You could do that about astrological facts, like astrology, just as well as you could do it about, like, say, general relativity has been axiomatized, and then logicians have proved meta theorems about it. And so that's not mathematical realism. If mathematical realism is be a unique and interesting position, mathematical realism has to do with the status of the axioms. But evidently, I don't just mean any axioms, because as you've already pointed out, some axioms question. There's no question about whether the axioms of Euclidean geometry are really true, as opposed to the axioms of hyperbolic geometry or elliptic geometry as pure mathematical axioms, as opposed to conjectures about physical geometry. So what is meant when the mathematical realist says there's an independent fact about which axioms are true is they mean independent fact about the foundational axioms. So canonically, the axioms of set theory, the axioms in which you can carry out you can prove the existence of the models of the different geometries, and you can prove meta-theoretic results more generally about different theories. So an example would be like a mathematical realist thinks that there's an independent fact, not just about what follows from ZFC axioms, those are the standard axioms of set theory, but an independent fact about whether the ZFC axioms themselves are true. So, an example of a controversial, relatively speaking, but certainly not in the sense that you would encounter a controversy over it in ordinary math class. An example of a controversial axiom we use a lot is the axiom of choice, that every set has a choice function. And the mathematical realist position is that, look, that's either true or false. The standard view is that it's true, and the fact there's alternatives to it, like a famous alternative is the axiom of determinacy, the unrestricted axiom of determinacy. But there's lots of weakenings of it and so forth. Doesn't say anything more about the truth or falsity of the axiom of choice than the fact that there's alternatives to evolutionary theory. I mean, evolution is either true or false. The fact that there's also creationism, who cares? So mathematical realism, a little more precisely, is the view that there are independent facts about whether the axioms of our foundational theories are true. It's not primarily this. One thing that's complicated here, confusing here, and I think obscures a lot of interesting debates that one could have, is right. Whenever you think of math, you think of proof. But what does a proof strictly establish? What it establishes is that some claim, at most it establishes this, because I'm, again, setting aside philosophy of logic, it establishes that some claim follows from some other claims that you've assumed, which are generally, you may or may not actually appeal to the axioms. Generally, you don't, but they'll follow from the axioms. So what you've really established at most is a conditional claim. If this, then this other thing. But of course, as I say, if you're a realist about logic, you think you can do that in any area. You could do that in astrology just by axiomatizing some astrological theories and then establish, So mathematical realism as a distinct and interesting position is about the status of the axioms, and not just any axioms, of course, because nobody thinks there's a serious question as to whether, commutative or non-commutative group theory is the real one, right? So okay. So then what are the kind of anti-realist views about?
Can I just add one thing to that? Because I feel like maybe even before the axioms, even at a more intuitive level, what about the reality of numbers, right? I mean, people learn about numbers before they learn about axioms. So can you say a little bit more about that?
Yeah, exactly. So right. So I mean, one of the interesting features of the history of math, which is again something that it's easy to just sort of set aside and not have inform one's philosophy of math, is that for most of recorded history, mathematics was not actually axiomatized. So we have as the paradigm, of course, Euclid's Elements, but that was if anything an aberration. There's books written on why did the Greeks axiomatize math and prove theorems. That's such a strange thing. The Chinese had advanced mathematics, the Indians had advanced mathematics, even like the Mayans had advanced mathematics of a kind of altogether different kind, and yet nobody was proving theorems in the sense of the Greeks. So the Greeks did that, and then for the Middle Ages, proof sort of once fell away, and Newton lamented in his Principia that he couldn't do the Principia, his book, in the way of the ancients. So it wasn't until like the 19th century, of course, that people became really concerned with foundations again and so on. So that's just to highlight your point, which is that long before axioms, there's just these intuitive structures, it seems like, at least in cases. It would be hard to argue there's intuitive, fiber bundles or something that everybody grows up thinking about. But at least when it comes to natural numbers, maybe sets of things also, we have some pre-theoretical intuition, and it's a good question then whether the axioms of specifically piano arithmetic, we can then, the case of set theory is much more, I think, messy, and we can't get into it if you want to, but at least in the case of piano arithmetic, there's a question of whether the axioms were sort of arrived at by some kind of combination of observation and like rational reconstruction, so that the axioms are more kind of like postulated laws of nature of numerosities. So there's an empirical, work on, of course, how we process numbers. And one of the things that's interesting about it is how limited our apparently evolutionarily innate mathematical abilities are. So we have, for example, this thing called the approximate number system, where we can like guesstimate the cardinalities of very small collections of objects and so forth. But if you think about how dramatically beyond anything like that the axioms of even first order piano arithmetic go, it's an interesting question how we got those axioms. Do we all, in sort of maybe the modern era, have this conception of a omega sequence built in somehow to our heads? I mean, that doesn't seem like it was evolutionarily inevitable. The Greeks, of course, didn't axiomatize arithmetic; they axiomatized geometry. So anyway, that's right. In the case of some mathematical structures, there's also just this idea that we have this given structure, and the axioms are trying to post facto correctly characterize it. And that's one way to give content to the idea that there's an independent fact about which axioms are true. Because we think we have, at least in the case of arithmetic, and there's an argument to be made in the case of set theory too, an antecedently understood, not understood, maybe intuited structure, and then we want the axiom to do justice to that. And they can be right or wrong, if we were to add, for example, that some natural numbers lack successors, it would seem like that would just get it wrong. Now, as you already anticipated, there's, when you really dig into the foundations, there's enough craziness so that you could probably find somebody who actually, I can name somebody, but I won't, who denies that. But that's exactly right. So the axioms on a standard realist view are not prior to our conception of the thing they're talking about. Our conception is prior, and then we try to do justice to them with some generalizations and some statements. And that's kind of, you might think, another argument for realism. The axioms aren't arbitrary. We're not just laying down random statements. We're laying down statements that are trying to get right something. What is that thing? So good. Yeah, good. So if you want, I can now say something about anti-realist positions in math, or I can say something about realist positions in math.
So is your answer to the realist answer to "are numbers real"? It sounds like what you're saying is that numbers are real since they are, I don't know, let's say conceptually prior things, and then our axioms are a way of formalizing that conception.
Yeah. No, it's a triviality that numbers are real if mathematical realism is true. So mathematical realism, one of, take the axioms of piano arithmetic, one of the axioms refers to zero. There can't be a model of that unless there is an object to be denoted by that numeral. So you can't say, truly that there is a number zero if there isn't a number zero, unless you're interpreting my language at an other than face value way. And part of mathematical realism is the language at face value. So that's exactly right. It's sometimes people say things like, look, I think there's facts that there's independent facts about mathematics, but I don't think that there's like, numbers in the sky. But it's a little tricky to figure out what you mean by that. I mean, if you think it's independently true that there are infinitely many prime numbers, then just by triviality, what's called the T schema, the claim that P is true if and only if P, if you think that's true, there are infinitely many prime numbers, then I can just go in one direction of that biconditional, and that's true just in case there are infinitely many prime numbers. You both have it that it's true and also deny that there are numbers. That's just, that's just what it means for it to be true. So now I might mention in a little bit, there are views, but they're known as anti-realist. They're examples of anti-realist views that don't take math at face value. So maybe, for example, whenever I utter the sentence P, what I really mean is if some axioms that are kind of contextually understood as true P, but you've just given us some reason to think that the axioms aren't just these arbitrary background assumptions. Some axioms we think are better than others when it comes to like getting things right.
I should actually say that if we had more time and if this were a much more rigorous course, as it were, we could talk about what it actually means to be real. But I think that's probably outside the scope of this conversation, to say the least, because that's what philosophers have been debating ever since the beginning of time, as it were. What does it mean to be real? So I guess for now at least, black box the word real and not worry too much about what real means, and just kind of have this intuitive notion of real and say, okay, this position says this is real, this position says it's not real, and then maybe later we can unfurl what that means. But I think at the beginning we don't need to worry too much about what real means in a very precise sense, more in an intuitive sense, I suppose.
I don't think for this. I mean, you're right. There's a huge conversation there, but for this purpose, what's meant is something really minimal. So all we mean is that like numbers are real if there's facts about them, there's truths about them that are not up to us.
Sure.
So there's some people say things like numbers are real in a different sense than electrons or something, but when we're using this just like thinnest of possible senses, like all that really comes to, it seems like, is numbers are different than electrons. I mean, we're just saying there's facts about both. Of course, they're different objects. They one exists in space and time while the other doesn't. But all we mean is there's truth about the thing, and they're not up to us. So in that sense, it's a claim about the status of the statements. You can move up the semantics and just talk about, are these statements the kinds of things that can be true or false, and do they depend on us? There's no into the as you say, the very heady debates about what it means for like how I mean the thing underneath what you're asking is what makes things true. And that is in fact a difficult question and probably not something to spend all our time on today.
Sure, I agree. Okay, great. So now that we've talked about the realist position, why don't we talk about the anti-realist position?
Sure. Yeah, and maybe I should just add an intermediate position because this is something we'll likely come back to. So I mentioned the realist position about math is there's independent facts about whether our foundational axioms are true. Now you can ask a particularly pressing kind of question in this context, which is what about the status of undecidable sentences with respect to the axioms? What I mean by that is sentences that you can prove are neither theorems nor is their negation a theorem if those axioms are consistent. So the classic example of this is the Gödel incompleteness theorems, but those are in a sense for this purpose less interesting because the standard view, and again we can talk as much or as little about the technicalities as you want, is that we can see that those are true by the proof itself. All we're learning are not provable or refutable. So it's something we're just learning about the limitations of any formal system, not about the truth or falsity of the claim. Now contrast that with sentences whose independence is established via fancier methodology like forcing, which is a method in set theory. The classic example, it was the first on Hilbert's list of famous open problems before he knew that it was independent, is the continuum hypothesis, which says that there's a bijection between any uncountable subset of the real numbers and all of them, or if you have the axiom of choice, which is equivalent to well-orderability, It's just the claim that the size of the real numbers is the next greatest after the size of the natural numbers. Um, so, uh, so you can ask, okay, suppose I think there's an independent fact about the axioms. What though would a realist say about something that's undecidable with respect to the axioms, like the continuum hypothesis is? And that is a point of disagreement among realists. So some realists think that there are facts about, roughly speaking, the axioms of Zermelo-Fraenkel set theory and anything that follows from them. Now, I say roughly speaking because arithmetic has a special place, and because of Gödel's incompleteness theorems, that will never be axiomatizable if the axioms are consistent. So basically, the axioms of set theory, there's a fact of the matter about anything about the numbers, but things like the typical undecidables of set theory. When you think of like undecidable sentences of set theory, like there's lots of them, like the Suslin hypothesis, all these things. Those are sentences on which some people that are realists think there's no fact of the matter. You can add the continuum hypothesis, you can add its negation, but there's no deep fact of the matter. Other realists, like Penelope Matty, is probably the most articulate defender of this, think that there's a fact of the matter about any sentences that any sentence you can form in the language of set theory. And one question is whether we know it and whether we'll ever know it. And another question is whether it's true. It's just like science. Nobody would say, oh, we'll never know whether they're a graviton. So there's no fact of the matter. That's just mixing up what we can know with what there is, what we can know with how the world is. So I just want to flag that is a sort of in-house debate among realists, but in a sense, it's a natural segue to anti-realist positions, because you could think that, look, the continuum hypothesis is the kind of sentence that makes people worry, right? You can prove that, you can't prove it, and you can't refute it. But wait a second, that's just the situation with any non-redundant axiom. So what's so special about the continuum hypothesis? I mean, axiom of choice, if you take set theory ever, you'll be introduced to the axiom of choice. It's one of the axioms, will be written on the board as an axiom, but like, what status does it have that the continuum hypothesis or its negation doesn't? Or there's famous sentences. Gödel himself identified one of them, the sentence being the axiom of constructibility, V equals L, which settles the continuum hypothesis and much else. So it has a lot of kind of like extrinsic support in roughly the sense that Zermelo thought the axiom of choice does. Zermelo argued, look, we need the axiom of choice. If you want to do stuff, you need it. Well, you can argue that V equals L, like, it settles all these questions that are like basically all the questions that are characteristically undecidable in set theory. It gets settled. So what's the difference between the axiom of choice and V? Is it just sociology? Is it that for some reason the kind of curriculum became codified in the 30s or 40s and now we have ZFC? Or is there a deeper difference? And one could think that the reflection on the case like the continuum hypothesis actually shows that kind of any axiom is like the continuum hypothesis. You can add it or its negation. You can ask questions about the consistency of the results theory. And you can, of course, ask the question about the fruitfulness of the theory, but there's no pie in the sky answer to the question of which combinations of axioms are really true. It's all just like the continuum hypothesis. That's a radical position, and you also almost certainly need to refine it slightly because of Gödel's second incompleteness theorem, and we can or can't come back to that, but I just want to flag that's kind of tantamount to the view that there's just no fact of the matter about what axioms are true. Like, choose your axioms and go home. And so long as you're not contradicting yourself, you can be criticized on the grounds that those are stupid or boring, not on the grounds that the world didn't cooperate. That's a kind of anti-realism. And the most familiar way to articulate this view actually says that known as formalism, actually goes so far as to say there aren't literally facts that our mathematical language is trying to report. That's a misunderstanding of the role of mathematical language in proof and mathematical discourse generally. So Hilbert had this famous program called finitism that I won't go into, but the key point is that he distinguished between two kinds of math. And one he thought of as contentful, And the rest he thought of as just a meaningless game. And the only thing you can ask about the meaningless game is, are you contradicting yourself? Or, what follows from what? And in particular, can you get 0 equals 1 from the axioms of this theory using these rules? And you can imagine having that view prima facie, because again, Gödel's second incompleteness theorem seems to show that this can't be true in general. But prima facie, you could imagine having that view just about all of math. Math is a game. It's a meaningless game. It's like chess. And you can ask questions about how you can move the pieces around and what kind of moves are possible. But there's no additional sort of statement of chess that the chess pieces are making. They're just pieces you can move around. And in this case, the pieces are the symbols on paper. So that the idea of formalism then is really this whole picture of the realist is just misconstruing math as a descriptive discipline that's trying to describe the world in the way that scientific statements do, when in fact, it's just a game. And it's a very fun game. It's a very productive game. That's what distinguishes it from chess, the productivity part at least. But it's not in the business of reporting facts about the world. Okay, that's one kind of anti-realism, because that's denying the truth claim, right? So the realism is saying they're independent truths we can hope to discover. This is saying, no, there's no truths because they're not even the kinds of things that can be true. To ask whether, there are infinitely many prime numbers is true is like asking whether, a chess piece can be true. That doesn't make any sense. Another way to be an anti-realist, and these just correspond to different ways you can deny realism, right? It's a conjunction of a bunch of different theses, and you can deny different conjuncts, is to say that there are facts of the matter about mathematical statements, but they're not independent of us. They're somehow our creation or depend on our practices somehow. And this is exactly what intuitionism is. Intuitionism is the view that, look, there's facts of the matter about math. It's not contra formalism. It is in the business of trying to represent things, but it's representing, depending on the intuitionist, possible mental constructions, possible acts of the mind. And depending on exactly what you think you mean by possible, what you think you mean by the mind, and so forth, you'll get different accounts of what axioms are tenable. So famously, constructivists reject, some classical logic and math. Different constructivists reject different amounts. But for example, the law of the excluded middle for any sentence P or not P is not a validity in intuitionistic logic.
So, what's the relationship between constructivism and intuitionism?
So, because it's just a different word for the same thing. Same thing.
I see. Okay.
Constructivism and intuitionism are the same thing. Okay. And the word says it all. Constructivism. It's the view that we construct mathematical reality. And there's a million different versions of this that are more or less radical. So, I mean, the most wild is called variously ultra-intuitionism, ultra-finitism, strict finitism. And this is the view that we can't even construct, the totality of the natural numbers. So even a claim like every natural number has a successor is at best like, well, I mean, the most extreme advocates of view would say it's false, or it's vague or indeterminate or something like that. And notice there, I just want to clarify a distinction that sometimes can be frustrating. There's a difference between talking about all the numbers and talking about a set of them. We're way past the worry, is there an inductive set? Is there a set of natural numbers? That's finitism alone already says you can't collect an infinite set. So ultra-finitism is saying, no, I can't even talk about arbitrarily large finite numbers.
I see.
So anyway.
Yeah, I would have, well, I guess these things are somewhat related, but I think I perhaps very incorrectly thought of constructivism as maybe a limitation of what you can do. For example, I would imagine maybe a constructivist might reject things like proof by contradiction, because I only consider things that exist if I can, construct them by hand, as it were, concretely finding an example, right? That a priori to me doesn't, I say, that can be an sort of a orthogonal axis on what's real or not real, in the sense that it's just basically a statement of what humans can know or something like that. It's not A priori
Well,
including those are the same thing, right? But maybe you're saying that it's common that those are somehow conflated.
well, no, this is it's you're absolutely your response is exactly the standard realist response, which is like one issue is what we can construct, another issue is what's the case. But the intuitionist and I should say that intuitionism it can be part of a much more general program called verificationism. So Michael Dummett is a famous advocate of the view that um, that intuitionistic logic is the true logic of the world, not just math. It's not just something about math. I mean, when you're reasoning about the future, for example, famously Aristotle worried, will there be a sea battle tomorrow? And this was before the block universe picture where, we thought that, we have the space-time manifold and we might not know the future, but it either holds or it doesn't. And Dummett thinks, certain statements anyway about that are unverifiable in principle, there's no fact of the matter. You don't get the law of the excluded middle holding for those. And that's a principled argument. I'm not endorsing it, but the argument is based on a theory of meaning, how words get to have the meanings they do. And the basic view is that, look, meaning is public. Meaning is learned by how people use it. So if you have some alleged meaning that distinguishes situations that you could not in principle manifest in your linguistic behavior, then actually that language has to be vague or indeterminate, despite what you're thinking that it's not. And this was a whole, movement in the early 20th century called logical positivism. But my point is, one version of it is just the view kind of all knowledge is the way certain intuitionists anyway think mathematical knowledge is. It's all limited by what we can verify. So the idea that there are in principle unverifiable truths is actually subtly incoherent. It's not just false. It's like you're actually not making sense. Now, that's not a standard view. I'm not advocating this view.
Okay.
I think
sure.
it's confused, but just so you know. Yeah.
Okay, I see that. Okay. Let's see. Have we covered the spectrum of anti-realist positions we wanted to cover, or is there anything else?
Well, the final one is just you could deny that mathematical statements are true, not because they're not in the business of truth or falsity, but because they are. They're trying to describe a reality like numbers or sets or whatever, and there aren't any. And so this view is known as fictionalism. And the idea, as the name would suggest, is that math is a lot like an elaborate fiction. Just like you can say sort of things that are true in the fiction, of Sherlock Holmes, like there's something better about the statement Sherlock Holmes smoked a pipe than there is about the statement he doesn't. And it's that it's like kind of true in the fiction that he smokes a pipe, but there's not really Sherlock Holmes, and there's no deep fact about whether he smokes a pipe. It's a fact about basically what follows from the fiction, or what coheres with the fiction, or something like that. So this is known as fictionalism, and there's lots of complications for anybody who wants to advocate such a view that sounds, of course, on its face nuts, right? It's on this.
This is the most extreme. Yeah, this is the most extreme position I've heard discussed.
Yes. So on this view, just in case the listener isn't convinced that it sounds nuts, on this view, the sentence 2 is prime, or let's say there are prime numbers, is literally false. It's not somehow like not in the business of stating facts or a move you can make, but it's not really descriptive. It is descriptive. It's trying to say something, and what it says, the world didn't cooperate. There are no prime numbers.
I see.
So that's the last version of anti-realism, I guess.
Is this some, how to say, in any philosophical position, you could be a skeptic and ultimately to the point of being a solipsist, and if you want to be staunch all the way down to the deepest level, no one can convince you if you want to be stubborn about your solipsism. I'm wondering, this fictionalism, I imagine, could be out of that strand, but to be fair to it, does it actually buy you something? So in other words, is there any benefit to having it? Because if it's just hardcore skepticism, then it's not that attractive. I imagine there is some fruit to it, right?
Yes, two things. The first is you got to distinguish, as you did a minute ago when talking about intuitionism, is metaphysics and epistemology. So this is not an epistemological view. Skepticism is an epistemological view. It's the view that we can't know anything from a given domain or in the classical tradition, period. So the classical skeptic is someone who literally says, I can't know anything, including that. I can't know that either, Now, fictionalism is not a skeptical view. It's taking a stand. It's making a claim. Here's something they claim to know. There's no numbers. And so mathematics is systematically false, at least any existentially quantified sentence of mathematics. That is something that starts there exists X such that blah, blah, blah. Is false. Universally quantified ones for all X, if, X is F, then X is G, that will be vacuously true because there won't be any numbers to witness the antecedent or mathematical entities. But solipsism is a metaphysical view, not a epistemological view. Solipsism is the view that I know what exists and it's just my mind. In other words, it's not a humble view. Like there's such a thing as radical humility. That would be the skepticism. There's nothing humble about fictionalism or solipsism. These are bold metaphysical conjectures about the nature of the world. Probably false ones, you might think. But so what's the point, though? That's a totally reasonable question about fictionalism. What's the point? And here is the point. I started this whole conversation off by saying that, naturalism, this is, this kind of like buzzword, is certainly a guiding ideal for an awful lot of work in the empirical sciences and in philosophy. The idea is that, it's something like a framework, kind of like before electromagnetic fields, you might say like materialism, were like the view that everything's a particle and causally bouncing around little particles. You might have thought that was like a framework that was very productive, and with the discovery of electromagnetic fields, it had to be generalized a little bit. It's not just, you have to take the field seriously too. But the idea of naturalism, it's not precise. No one could claim it's precise, but it's a very productive framework. And advocates of fictionalism, the most famous being Hartree Field, feel like, look, to plop on to naturalism, Platonism. That's the sort of diminutive word that's used for just mathematical realism. Same thing. It's just a word that the people who don't like it use. Is kind of like reverting to the Middle Ages or something. I mean, if you take seriously the idea that along with, fermions and bosons and, maybe gravitons and whatever ends up being the completion of the standard model and gravity and dark matter energy, whatever, there's, like the number two, and I don't know, like vectors in a Hilbert space and so forth. I mean, okay, what's the connection between those two worlds? I mean, what is a number two? Is that something that, if we build a big enough particle accelerator, we'll get to discover? I mean, the idea is like there has to be something wrong with the view that the final theory of the world involves a whole bunch of, again, using diminutive language, Platoplasm up in Plato's heaven, along with the causal world with which we interact. Okay, but that raises a serious problem, which is, okay, give us the theory then that doesn't use the Platoplasm. And this is really where the rubber meets the road with fictionalism. So what is fictionalism more than just a slogan? It's a research program to do away with reference to mathematical entities.
I see. So maybe stated in a more positive way, it's kind of like a minimalist naturalism.
That's right. It's an attempt to sort of like you might feel like, okay, I'm a naturalist, and then you learn, as I am suggesting today, that naturalism involves commitment to Plato's forms, basically. You might be like, oh, well, okay. I mean, that's not a very impressive naturalism. Like, I mean, I thought naturalism opposed to the kind of Mysteriantism of the scholastics and stuff, but no, you're saying it's kind of like both. So people like Field, I mean, and Quine was very much in this tradition. Quine, in a sense, inaugurated this tradition, but came to believe that this project couldn't be fulfilled and became a reluctant Platonist. So Quine is like, I mean, ruthless in what he believes in. He believes in little as you can possibly believe. He doesn't believe in consciousness as we think of it. He doesn't believe in states about like belief, like Joe believes that snow is white. He doesn't believe in facts about possibility and necessity. I mean, all these things. but he felt like I can't get rid of math. And Quine is Field follows Quine, where the basic idea is if you're going to say something like there aren't mathematical entities, you got to put your money where your mouth is. You can't out of one side of your mouth say I don't really believe in numbers, and on the other side, a sort of physical theory that's up to its ears in numbers. That's just called a contradiction. So to their credit, like their view sounds nuts, but they're actually trying to fulfill the ideal that I think most naturalists come to the table with. It's like the physical world and the world that we interact with, and that's it, like, but if it turns out that also there's Plato's forms, like that seems like a little bit of a letdown, like, and so that's the research program.
Okay, that makes a lot of sense, and it sounds much more reasonable and even some ways attractive now that you've mentioned it that way. But yeah, in the interest of moving forward, why don't we maybe go ahead and talk about the moral versions of realism and anti-realism?
Good. Yeah. So, I mean, we can be a little quicker with this because once you have the distinctions on the table that I've drawn between, what is mathematical realism, what are the different ways to deny it, there's basically exactly parallel views about ethics. What is moral realism? It's the view that they're independent facts that we hope to discover. We don't get to make them up. Ethics is in the business of discovery, not invention. And these facts obtain independent of what anybody thinks. So, whole societies can be wrong about what's good or bad. Everybody might, that that maybe like eating animals is okay, and we could be wrong about that. Like Peter Singer thinks we are wrong about that. So moral realism is just like mathematical realism, except that of course it's talking about moral facts, and moral facts concern things like you, me, and actions, like people, actions, and events, rather than some special realm of objects. But they ascribe properties to them that are unique to morality, like goodness and badness and rightness and wrongness, and there is a reason to do and obligatoriness and so forth. And I should just flag that though we'll be talking about ethics, you can think much more generally about normative thought. So normative thought is just thought that involves norms. And if one way to convince yourself that it's kind of like an interesting question what to think about ethics is to think about, before you even start thinking about analogies to something as apparently far away as math, think about analogies to things that are very similar on their face, like epistemology, the theory of what you ought to believe given some evidence. Or think about logic. Logic officially concerns what follows from what, but we don't just want to accumulate, like a phone book full of facts about what follows from what. We think that has to do with what to infer from what. But that's a normative subject. The subject, you ought to infer Q if you fully believe P and believe if P then Q, is a normative claim. It's a different kind of ought than moral ought. But you can ask yourself, like, if I want to be an anti-realist about ethics, can I be a realist about say logical norms? And if I am a realist about logical norms, what kind of facts would those be? Are those natural facts that the physicists are going to discover? So that's one way to get yourself interested in ethics from a meta-ethics point of view. If you initially feel kind of like, I don't see why anyone would take this seriously, moral realism.
Sorry, just to clarify, you distinguish between different kinds of thinkings or oughts there. So, so I feel like, ought is a very general term, but there is at least ought in two senses. Like, you ought to do X, full stop. There's no axioms there. That's just a statement about, like, I guess, what is morally true or good, absolutely. And there are statements like that, I guess, like you ought not kill, right? That's usually kind of unqualified. There are subtle cases, like the trolley problem, but okay, you ought not kill. And then there are, if X, you ought to do Y, right? So could you clarify? I think you said there's a distinction between these two cases, or was that not the point?
Well, so that's a sort of different issue, but it's worth making. So Kant distinguished categorical from hypothetical imperatives, and the idea is just that one kind of imperative is always conditional on other things. So maybe, for example, anyone would agree like to imperatives of prudential reasoning. Prudential reasoning has to do with kind of reasoning in your own self-interest. So if if you really like sweet things, you should eat the cake, or if you really want a sweet thing right now, you should eat the cake. If you don't want a sweet thing, you shouldn't eat the cake. There's no just once and for all fact of the matter about whether you should eat the cake. It depends on what you want. By contrast, just like in the mathematical case, where you have on the one hand a kind of uncontroversial fact about just logic, which is there's facts about what follows from different sets of axioms. That's just logical realism. That's realism about the view there's facts about what follows from what that we don't make up. But mathematical realism, remember, was the idea that there's just categorical facts about what axioms are true, at least when it comes to the foundational axioms. Similarly, in the case of ethics. So, for example, just to give you an example, like what would these be in the case of ethics? Well, a very, very influential framework, especially in the current age, arose with Bentham and Mill. Mill actually is Bertrand Russell's godfather, but called utilitarianism. And it can be precisified in lots of different ways. So it's really a family of views. But essentially, the view is that you ought always do what will maximize happiness among the most number of people. Now, there's a bunch of, terms there that you have to choose a definition of. What do you mean by happiness? Mill himself thought there were different kinds of happiness that have to be weighted differently. What do you mean by people? What I mean by that is not just like what counts as a sentient being. There's also the question of whether do you take future generations into account? And this quickly leads to some paradoxical conclusions. And also there's an issue about actually should this be understood as a sort of norm of conduct, because you might think it would be infeasible to figure out maximize happiness in any given situation. So I just froze in doing nothing if that were literally. So some people distinguish between decision guides and sort of the facts about what to do, but setting all that stuff aside, that would be an example of something that a moral realist thinks, look, that's either under some precisification, that's either right or wrong. And that disagrees in a very concrete way with other views like Kant. Kant famously held, that you ought never treat another person as a mere means. So let's take a concrete case, that's infamous from the ethics literature, the trolley problem, right? So there's a trolley coming down and you could push somebody onto the tracks, thereby saving 5 people. You know that they won't see the trolley or something and whatever. Or, organ harvesting. You imagine you can take the organs out of this one person, killing that person and saving 5. The utilitarian is very straightforward. If you cook up the case correctly, committed to the view that, yes, you ought to do that. And nobody said it was easy. Nobody said that being good is always easy, but that's just what it is to be good. And that's the truth. But Kant is very explicitly denying that. You're just blatantly using the person as a means for some other end. You're not treating them as an end in themselves, as he would put it. So the point is, when an ethical realist says there's independent ethical facts, they're not just saying about there's independent facts about what follows in an ethical framework, or even merely conditional facts that aren't logical truths, like if you want the ice cream, if you want something sweet, eat the ice cream. They're saying there's all things considered facts about what basic values you should promote.
Right.
And of course, by itself, that doesn't prescribe anything. You need to know the fit. You need to know the natural situation. So if I tell you, here's the, God talked to me, and here's the answer to the question of what you ought to do. You ought to maximize utility. Okay, well, under some precise characterization of utility, of course, you now need to know concretely what will do that in different situations. That's an empirical question.
So actually, just to pause, so let's think about like moral realism and comparing it to mathematical realism. The analogy of like, okay, well, should you? So there's an assertion that there are independent moral facts. It may be that you should follow the utilitarian perspective or the Kantian perspective, but that's going to be analogous to. So in the mathematical case, like, oh, there is a fact of the matter whether the axiom of choice is true or whatnot. Is that kind of the point you were trying to make? Sort of like saying these are the axioms that are correct.
That's exactly right. And I just because this pedantic point will maybe matter later, depending on what we talk about. Exact analogy is that that the principle, say, of utility or greatest happiness principle also is true independent of us, just like the axiom of choice is true. What you said was we should follow it. That's actually raising issues that we can talk about, but it's a different issue. So at
Okay.
the moment, we're just saying that at the level of epistemology, the theory of knowledge, there's a perfect analogy between the basic principles of math and the basic principles of ethics, at least in the sense of their independent truth.
Mm-hmm.
That's what moral realism is.
Okay. Okay. Great. Okay. Let's. Okay. Great. Thanks for that clarification. So, okay. So yeah. Right. So moral realism is this assertion that there are independent facts about, I guess, morality. I guess we never defined exactly what morality is. I guess it's basically what's good or bad. Although I'm not sure we want to go into that. Yeah.
Good and bad are ambiguous in the same way as odd is, right?
Yeah,
so
that's right.
One of the issues is that that there's supposed to be a primitive kind of goodness, badness, oughtness, and so forth, a whole family of concepts, which is the attitude and the property characteristic of morality. And that's what distinguishes it from prudence or epistemology, or maybe there's such a thing as all things considered ought. You mentioned that earlier, but that's actually, some people think that's different from moral ought. So right, it's kind of similar there to moral realist. It's kind of similar, like suppose somebody said, what counts as a mathematical property? I mean, it's like, when you see it, give me a break.
That's right. That's right. Yeah. I mean, they're kind of orthogonal. Like, what is the scope of the subject matter and whether it's real or not? So, right.
That's right.
Yeah,
that's
exactly. Right. Okay. So, okay, leaving aside what is actually the scope of morality. So you briefly talked about the trolley problem and what distinguishes the perspective if you're a utilitarian or a Kantian. At some point, I want to talk about anti-realism. So, if what would how does an anti-realist think about the trolley problem?
Well, right. So, just like in the mathematical case, there's going to be different kinds of anti-realism depending on which component of realism you're denying. And so, remember in the mathematical case, I mentioned really four views. First, I mentioned what has come to be known as if-thenism, the idea that there's independent truths, but they're not the truths that we seem to assert at face value. So whenever I say, that if somebody says the twin primes conjecture is true, what that really means is that if the Peano axioms, then the twin primes conjecture, something like that. Now, it can't be exactly that for technical reasons I won't get into. But okay, so we've got if-thenism. That's just like relativism in ethics. Relativism in ethics says, look, there's facts about what's true according to different ethical frameworks, but there's no once and for all, like, pie in the sky framework. That question doesn't make sense. Okay. I then talked about formalism. Remember, that was Hilbert's view that in some sense, like, mathematical claims aren't in the business of describing anything. They're pieces in a game that you can move around. And in that sense, math is just like one big chessboard, So that's the idea that mathematical statements aren't trying to describe anything. They're not strictly speaking, like in you categorized initially math with science. Math is not like science in a crucial respect on this view. It's not trying to describe the world. Can't be right or wrong. And that's the wrong way to think about it. There's a view in ethics that's similar, and it's called emotivism. And it's the view that when we say something like killing is wrong, to use your example, we're not asserting a proposition that can be true or false at first pass. This gets all much more sophisticated and complicated these days because of things that we can talk about to do with the theory of truth. But at first pass, it's not the kind of thing that can be true or false. It's just a way to vent emotion or to somehow to express disapproval. Think about a sentence or not a sentence, an expression that nobody thinks is true or false. Like you're at a Mets game and you're saying boo. That's an expression of something. That's a linguistic act. But nobody thinks that, but nobody would object to your boo with that's false. They might say, hey, but they won't object that you got the world wrong. Well, the emotivist idea at first pass is that when you say something like killing is wrong, that's dressed up syntactically like a declarative sentence. So we're naturally inclined to think, oh, you're trying to describe the world. Does killing have the property of wrongness? But what you're really doing in this dressed up language is just doing something like boo killing. Something like that. Not literally, of course, for all sorts of reasons. But So the analog then to formalism in the ethical case is emotivism, or also called non-cognitivism, about ethics. Okay, there's an analog then to intuitionism, which is also called constructivism, as you pointed out, which is the idea, remember, that there are truths about math, but they depend on us. That's exactly the view that goes by the same name, constructivism in ethics. Kant was, for example, a constructivist in a certain sense about ethics, and Christine Korsgaard is a very famous neo-Kantian constructivist. That's the idea. There are totally facts about what you ought to do, but they depend on us in some important way. So they're not going to be about what mental constructions you can perform. It's a different kind of mental dependence. But they might, for example, be about like what follows from your self-conception as an agent or something like that. That's loaded language, and I mean, it's different people will different just like in the intuitionist case, different people have different stories about how they depend on us. But and then finally, we said
Actually,
there was
just
fiction.
on this note,
Yeah,
I'm a
go ahead.
little confused because somehow I don't know enough about the subject, but calling Kant a constructivist, I would have thought that seems he's famous for this categorical imperative, which seems unqualified. So can you kind of reconcile
Good,
that?
good, good, good. So this is a great opportunity to yeah, make some philosophers love distinctions. I love making distinctions. So right. So Kant is, the paradigm of someone who thinks there's just hard and fast rules, right? I mean, and so hard and fast, exceptionless rules that, you've got these famous objections about, like, if the Nazi knocks on your door, are you allowed to lie, and so forth. And it's crucial to distinguish realism from context. Well, sorry, I should say relativism or constructivism from contextualism. So let me explain what by contextualism, what I mean is that what concretely you ought to do in a circumstance depends on the text. So if you think back to utilitarianism, that's a contextual view, because it's going to say, okay, you always ought to maximize utility. But what that means, what that involves, will depend on where you are, what society you're living in, what makes people happy, and so forth. So the idea, like, you ought not lie, that won't be something that a utilitarian will get behind generally. That's why they are in disagreement with Kant about this, because whether you ought to lie depends on whether you ought to maximize utility, and that depends on the context. Okay. However, utilitarianism is totally consistent. In fact, I was assuming when we were talking with realism, the idea that the facts about ethics do not depend on us. We don't make up the ethical facts. Now, they're highly context dependent, but that we don't make up the context of the ethical facts. Okay. Now think, though, you can have the converse. You can have the situation where the ethical facts are like Kant thought they were, but if there were, say, no human beings to make ethical judgments, or there were no cognitive apparatus to structure our thinking, which is the way Kant thought of it, there would be none of these categorical truths. So the idea, one is categoricity, and two is a dependence on us.
I see. Is this consistent with his views on space and time, that somehow maybe they're not out there existing, but they're some of a feature of our minds in some sense? Because they're like a priori necessities of how we sort of understand relationships in causality and things like that.
Yeah, exactly. So Kant famously, he was a founder of transcendental idealism, which was, basically an attempt to explain how is metaphysics possible, because he was very worried by the kinds of skeptical arguments people like Hume brought up, where it doesn't seem like we could know about a mind and language independent world, but we do know things like, that the sun will rise tomorrow. Or he thought actually you could know just by thinking Newton's laws. Whoops. But the way he reconciled all this was exactly by saying that, look, there's a world, and we don't. It's not like, it doesn't vary from person to person or from context to context. The structure of space time is the same for everybody. Same with ethics. The ethical rules are the same for everybody, but they depend on us. So like, in a sense, the world is this synthesis of contributions from the outside that we can't even imagine in any useful way, and the way we structure those contributions. And the point is, one issue is, are universal rules that everybody has the same ones. We're all answering to the same truth. And another is, do those truths obtain independent of human minds and language?
Yeah. Yeah,
His answer
I don't
to
want
that,
to. Yeah, I don't want to linger on this point too much because we should move on. But I think this sounds to me somewhat like a kind of a hybrid realist anti-realist approach in the following sense. It's saying that there is something real, which is that we have something shared. We're not all hallucinating independently when it comes to what's true out there. But nevertheless, since it's contingent upon our structure, as it were, then it's not real in some sense of like, I don't know, like Newton's laws being real independent of us, right? So
yeah,
it's some kind of hybrid, I would say.
yeah, that definitely the trans idealism is hybrid. I just would want to flag one thing, which is that I don't think you would that the agreement or consensus is sufficient for the hybrid. I mean, you can imagine us all being born in and indoctrinated with some rules about etiquette. Everybody agrees you ought to put your fork on the left side of your plate. Everybody agrees you ought to drive on the right side, whatever. I mean, so there's no disagreement. It's completely uniform. Everybody agrees. But that wouldn't, in any deep sense, make objective or real or anything like that, even partially. That's just sociology, you know?
Right.
So there's something a little more going on than
Sure,
just,
sure.
yeah.
Okay, great.
Um,
Yeah.
yeah. Yeah, and then
Okay.
the fictional view is the analog to fictionalism. So remember we said that somebody like Hartree-Field thinks that statements like 2 is prime. They're trying to just say something true about the number 2, and they fail because there is no number 2. So math is systematically in error. You talk about what's true in the fiction of math, and typical claims will come out true in the fiction of math that we would regard as just true. Something like an undecidable will probably be neither true nor false, like the continuum hypothesis, because the fiction doesn't decide. Well, there's an analog to that view too, and this is in the ethics literature called error theory. The best way to think about it is on analogy with like theology. So it's the analog to atheism about God. Like you can like the way to think about it is like if you think seriously about moral language, what is it trying to do? And maybe I for my own for my own purposes, I find it more useful to think about moral deliberation, like first person moral experience, not like kind of as a sociological matter, but rather think about when you ask yourself what ought to do. I think that's the most powerful way to get in the headspace of a moral realist. We don't treat it like something we can just stipulate the answer into existence. We don't want to get it wrong. We want to do the right thing. We take it seriously in the way that we take any question that we think there's a fact of the matter seriously. Well, so the error here thinks that's the right way to think about it. Ethics is trying to get right independent facts about how we ought to live our life, but there aren't any. The world did not come equipped with that. So just like in the fictionalism case, you still might talk kind of true in the fiction of morality or something like that. But systematically statements like, you ought not kill people for the fun of it, strictly speaking, that'll be false, or anyway, truth valueless.
Yeah, where does this term error come from?
Because the thought is the famous advocate of this view is John Mackey in his book Ethics Inventing Right and Wrong from the 70s. I think the famous chapter is available all over online as PDF. It's the first chapter. But it's called error theory because on this view, we are systemically, except those few among us who have taken the time to think through it and come to be convinced of Mackey's view, we are systematically in error. Just like someone raised in a religious household who comes to believe in a monotheistic God, if there isn't one, is in error. So again, the analogy to think through is the analogy to theology, where few people would say there's no fact of the matter as to whether there's a God. It's not like that's a statement. To say there's a God is a statement, and you could have debates about how to define God, but once you've defined God, there's a fact of the matter about whether there is or isn't. So atheism isn't a view that it's like meaningless or that we're in a different business. It's the view that nothing is true of God except that he doesn't exist. There isn't one. Now, whether or not you believe that atheism is the right view, my point is just this is the analogous view about numbers on the one hand, that's fictionalism, or about values in the case of ethics. So that's the last form of anti-realism about ethics.
Yeah, I'm
that
just trying
maybe.
to I'm trying to distinguish it from the other things that you described here. Like, for example, how is error theory different than if-thenism?
So the difference is about the semantics, and by that I just mean the meanings of the statements out of our mouths. So an if-thenist or a relativist would agree that there aren't objective values out there in the world to be discovered by us. But the relativist or the if-thenist in the mathematical case thinks that when we say something like, killing is wrong, we're not trying to talk about objective values. We're saying something like it's shorthand for something like, according to my culture, killing is wrong, or according to my values, or maybe there's all sorts of much more sophisticated ways of doing the same basic move. So the point is, we're not in error, because what we're actually saying with sentences that look like they're ascribing objective values, something which is totally consistent with there being none, because it's just a conditional statement about what would be the case if there were any. The error theorist is saying, no, we are trying to describe objective values, and so we're systematically in error. So think about the mathematical case again. One view is, when I say 2 is prime, I'm trying to talk about a number and ascribe it a property. So if there isn't one, I'm wrong. If-thenism, by contrast, is saying, when I say 2 is prime, I'm not trying to ascribe a property to the number 2. I'm saying if the Peano axioms or something like that.
I see. Okay, I see. Okay, so just follow through the analogous mathematical version, and then I guess that distinction will become clear.
Yeah. I hope so.
Yeah. Actually, just one last point, because we did start off by kind of saying, okay, I think most scientists, most naturalists are mathematical realists, but moral anti-realists, and I would identify with that position as well. It seems to me always been the case. I don't know which of these four I would kind of most identify with, maybe the if-thenism, but sort of to me, and I think this is maybe the intuition, correct me if I'm wrong, sort of even something as universal as killing is wrong. I've kind of thought to myself, like, well, what if we were like earthworms that could regenerate, right? Maybe killing wouldn't be wrong. It would be an inconvenience, because if you killed me or slit me in half, there'd be 2 of me, and that in such a world, killing would be, again, more of an inconvenience than maybe the status that it has here, where you've ended a person's life, full stop, right? And so that's the sense in which I've always thought, well, morals are therefore conditioned on our human condition, right? Also dependent on us. It's also kind of like maybe this constructivist perspective, and in a way that it's not like I think that, the value of pi depends on something, or the laws of physics depend on something, right? So that to me has always been intuitively why mathematical realism is the case and moral anti-realism is the case. I don't know if you have any thoughts on that, but I think that's kind of the rough idea of my intuition.
Yeah, so that I would say is not an argument against realism, because that's just contextualism again. So like, for example, Darwin speculated, if we were all raised like hive bees, we might think it's like our obligation to kill our brothers or something. I forget, something that something that hive bees do as a ritual, and the idea is that what you ought to do in different circumstances. It could be that there's a completely mind and language independent fact, if you give me a circumstance, how to do in that circumstance. But it varies a lot, because maybe, say, principal utility is true, and what maximizes utility depends on the kind of creature you are, how much money you have, where in the world you live, what time period you live in. But that's not anti-realism. It's saying it's a mind and language independent fact that you always ought to maximize utility. What will maximize utility depends a lot on who you are, where you are, blah blah blah. But you see, like, this is
I see what you're saying. Yeah, this is, in some sense, this is a much more academic distinction than sort of the usual talk about morality being real, in the sense of, like, let's just be like, a very cheap example would be like the 10 Commandments, right? There are no qualifiers, like thou shalt not kill, right? So that kind of realism or absolutism, whatever you want to call it, that's the thing that my argument would refute, right?
That's right. But as I said a minute ago, like, that goes both. You could be an anti-realist and think that there are the 10 Commandments are true, right? I mean, Kant was an anti-realist, but thought you can never lie. So one issue is one issue is there's simple rules that we always ought to follow. Another is, what's the status of that ought claim?
Sure. Okay. That was really great that we got to go over those introductory topics, Justin. I think now maybe it's time to actually go into the weeds of your book. Um, Looking over our outline, we already covered to certain degrees the disagreement in mathematics. So I guess maybe we could start off with chapter 3 on empirical science and justification. I think it also makes sense because the right out of the gate, you started talking about naturalism and why that sort of set the stage for things. So I think that's maybe good to revisit that. So yeah, why don't you take it away?
Yeah, sure. So um, there's a question that arises in both the ethical and the mathematical cases that you might think admits of a simpler solution in the mathematical case than the ethical case, and this is going to be a theme that repeats, which is what justifies our beliefs. So, justification is a technical term philosophers use, but the intuitive idea is just like, why is it reasonable to believe most of what we believe in the two cases? So, for example, you believe there are infinitely many numbers. Why is that better than the belief that the number of stars is even? And you can say something initially about that is obvious, which is, well, you can prove it. But that just delays the question in the way that we talked about, which is that, okay, you can prove it from some axioms. Now, why is it reasonable to believe those axioms? And this is where you often hear people appeal to things like self-evidence and so forth. So, intuitive obviousness, Gödel said that the axioms force themselves upon us as being true. And chapter 2, which we've talked about some of the relevant stuff there, is about that whole sort of tradition of thinking mathematical knowledge and moral knowledge, because there's an exactly parallel point of view about ethics, that what justifies us in believing maybe the principle of utility or Kant's deontological framework is that it strikes us as it passes intuitive muster, passes reflective muster when we just think about it. It's an armchair question. But this is exactly where the thing you pointed out before comes up, which is that the sociology can be very misleading because, in the mathematical case, it's just not a normal medical activity to ask what axioms are true. In fact, I suspect I'd be interested in your experience. My own sense, talking to my mathematician friends, is that most of them never even took a class in set theory. Axiomatic set theory. I know everyone learns about naive set theory and different, but so if you ask the mathematician on the street, what's your view of the axiom of replacement? If they have a view, they were just taught the axiom of replacement. So there's no it's not like it's not a question that seems to be part of normal mathematical training, and that can easily give one the impression that sort of the mathematical community have thought through these things, and their conclusion is we're good with the axiom of replacement. Like, that's a misleading characterization of what happens. Even in mathematical logic and set theory classes, you don't normally talk about, you don't debate the axioms. That's for philosophy. That's quarantined in philosophy departments. And there's a reason it is, because the primary project and productive activity that mathematicians have tended to succeed at is proving theorems. And if you had to settle what axioms are true first, you'd never prove any theorems. You'd just be debating the axioms, and it would turn math into philosophy. So we have this division of labor where the debates about the axioms happen in one department, the what follows from them happens in another, and it seems like more of a kind of contingency theology that it's the ZFC axioms that show up in chapter of the real analysis book you use or whatever. Now, in the ethical case, though, it's exactly the opposite, right? Ethicists don't want to know what follows from some random selection of moral axioms. They want to know which axioms are true. Exactly the opposite, because in the ethical case, you want to figure out how to live your life, and you can only go one way or the other. At any given circumstance, you've only got you can only do one thing, so to speak. By that, I don't mean that you only have one choice. I mean that any choice will preclude the others. So you can't take it's like geometry attitude towards ethics. And so in ethics, what's front and center, what's familiar, is disagreement. But that's kind of not necessarily, could be, but it's not necessarily a deep difference with the mathematical case, because the projects are different and the sociology is different. So one question is just if you look at the standard approach to justifying basic principles by, reflecting on their intuitive plausibility, is there an important difference between math and ethics? And so chapter 2 is arguing that there really isn't. There's all these kind of very misleading sociological differences. But there are advocates of all the different, all sorts of alternative axioms, all sorts of wildly heretical points of view. We've seen at the level of philosophy already, but it's true at the level of just what axioms are true. Okay, so is there
Actually,
any other?
Can I just qualify that? I think there's one, because this is one thought I had after I studied your book a bit, which is that I think what you say is correct, and I think you meant this too, which is that there's analogous controversy at the level of foundations of math and morality, but mathematics itself in the business of theorem proving, like there isn't any controversy about, say, the Pythagorean theorem, right? Like we like in some sense there are too many ways to formulate Euclidean geometry, but whatever you consider the ground level, whatever controversy there is there, like there is no controversy at the level of Pythagorean theorem or any other theorem like it, right? So that's just maybe one qualification I might add in terms of math versus morality. I don't know if that's how you think about that.
Yeah, so I agree with you. And what I would add is, again, I think that's like not an important. I mean, not it's there's different purposes, but it's important for our purposes here today. I think that's not a very telling difference, even though it totally seems like it. So here's a very natural thought, which maybe this is what you're saying. Okay, so you say that in math we focus on what follows from the axioms, but in ethics we can't even agree about that. So that's a difference. But that's a very I think that's a very misleading difference. The reason we agree on what follows from the axioms is because mathematics was rigorized in the 19th century with the development of mathematical logic, and we developed a rigorous notion of what counts as a proof. In principle, something is provable in math if you could formalize it in first order ZFC, such that every sentence in some finite sequence of sentences is either an axiom or follows from a previous line by a rule of formal inference, the last line of which is the claim proved, or the surrogate for the claim proved in the language of ZFC. So the point is that the mathematical community decided that it was productive to agree on a standard of rigor. But it's not like the debates about logic went away. Those just also got quarantined in philosophy departments. And so what you're strictly speaking, establishing when you prove a mathematical theorem isn't even what I said. I said it's that if these axioms, then this theorem. It's actually even more Baroque than that. It's if these axioms and classical logic is true, then this theorem. But there's disagreement over classical logic between intuitionists we've already met, but it's not just intuitionists. There's paraconsistent logicians. These are logicians who accept the logical possibility of contradictions. The logics that are paraconsistent tend to be extremely weak. What you can prove is very, very limited. So as a sociological matter, once again, I think you're absolutely right. But the reason I think is that it's not just that math is conditioned on some axioms that are uncritically accepted. It's conditioned on a logic which is uncritically accepted. In fact, I suspect that it's not even a widely known fact that there are alternative logics that are really different.
Yeah, I think I meant something much more mundane, and
okay.
Like this would take us too far. But like, there's a sense in which the Pythagorean theorem is true because you can just take out your ruler and measure it, and there's no controversy about what the lengths of the sides of a triangle are. And maybe another analogy is there's no controversy about, let's say, like shipbuilding, right? Like, because we know how wood works and how to piece them together. Our understanding of wood went from, I don't know, the elements of fire, earth, and air and water to atoms to now quarks, but that didn't change the nature of how we build ships per se, right? So there's a sense, that's the sense in which there's like not controversy in mathematics in sort of that sense. Like it doesn't affect the practice of mathematics, right? That's what I mean.
This brings us in, as you say, exactly to the chapter 3 about the sort of empirical scientific bearing of mathematics. So in other words, what I would say initially to what you just said is, well, that's all actually empirical. That's applied math. That's facts about the world. If you're literally a ruler, you're learning things about you're learning things about facts about geodesics and so forth in space. You're not learning about some arbitrary space that is your pure mathematical interest. And similarly, like if you somebody might say, like you can just prove that 2 + 2 is 4. Take any two things, take another two things, and then count them. And I just used the word two, but you can say what I just said in first order logic alone with no reference to numbers and count them. That's just an empirical truth about the world that you can establish. But my thought would be that once you move beyond the rudiments of applied mathematics, the kind of thing that the Egyptians were doing, you're going to have to be relying very much on what follows from the axioms. That's going to be the meat and potatoes of what you're establishing, and that's going to go beyond things that we observe, even that there are infinitely many numbers. I mean, you can prove that by assuming, 3 axioms of the successor function. But can you prove that in any simple empirical way? I don't know how. It seems like an open question whether the universe is finite. So anyway, but this brings us to the third chapter, which is, I think, where you're coming from is it's where Harman's coming from, and this is exactly why I have a chapter on that. So we were talking about justification, and there's this traditional view. Justification comes from basically like intuitive reflection. Math is an armchair discipline. It's not an empirical science. But maybe once you realize that, okay, if you think of it that way, it doesn't really look like there's all that much of a difference with ethics, because you can disagree about basic principles. There doesn't seem to be any way to resolve those disagreements, blah, blah, blah. Isn't there this difference, though? Math is applied to the empirical world, and ethics isn't. And this is exactly an argument that Harman made. Really, Harman was a student of Quine, and Quine was an empiricist. And here's the kind of empiricism he advocated. Here's the principle behind his empiricism. We're justified, or it's reasonable, to believe in all and only the propositions that figure into the best explanation of our observations.
Actually, is this where you might maybe want to write that? Because I think you could summarize that
Yeah,
in text in the way that I can. Yeah. Let's unpack this a bit now that we have it in front of us.
Yeah. So one thing just to note is the all and only. So there's 2 directions this could fail, and in which it's controversial. So the all is controversial for the reason that we've kind of touched on in discussing math's role in science. So math clearly figures into the best explanation of our observations that we have anyway. But you might think that its role is different than the role of, say, reference to electrons or gravitational fields and so forth. A common view, for example, is that, this is Hartree-Field's view, that reference things like numbers or space-time sets of points in space-time. These play a representational role in the theory, where they're representing the real physical quantities. And one view is that we shouldn't believe in everything that figures into the best explanation of our observations, because if something's merely playing a representational role in the best explanation, that's not reason to believe in it in the way that, say, if something's playing a causal role, like actually, causing events to happen, like, say, if Harman has this example, if you're outside a bubble chamber and you're looking at a screen and you see a streak on the screen, and you say, oh, a particle whizzed by. The idea there would be that the particle is playing a causal role in your observation, but there's no analogous role played by any mathematical entity in that story. Now, for my part, this is just biography. I doubt that there's actually a useful way to maintain that distinction at the end of the day, once you move again beyond sort of simple cases. Like, I'm thinking about this right now because Sean Carroll wrote this response to my book, and I think he wants to have this kind of view about math. Math, he believes in reality. He doesn't believe in the math that we use to represent the reality. And yet, meanwhile, I understand his view. I mean, he's an Everettian about quantum mechanics. So at the end of the day, there's just the state vector in Hilbert space obeying some relativistic surrogate of the Schrodinger equation. And I don't know what the cash value of calling that thing physical is. I mean, that's exactly the kind of thing somebody like Hartree-Field wants to get rid of. Like he wants to say, what is the physical correlate of this mathematical object, the universal state vector? It's like it. And so if you say, well, that just counts as physical, then, I mean, and actually, I would love to hear your view on things like, if you think about, the local gauge theories and the, fiber bundle spaces, the internal space, like isospin space and color space and so forth. I mean, like there's a way to sort of apply Field's program that he applied it to space-time. There would be a way I could imagine to generalize that to these spaces, but I don't see the point of like, I mean, it's just as mysterious how we could know about them and so forth. So
maybe be able to summarize what you're saying. I think my very gut feeling, but I think this is just maybe a reflection of me, is that at some point there actually isn't a distinction between physics and math. You are just doing math, and certainly for me, I've never gone out and done any experiments. I think most theoretical physicists, they might be aware of what the experimentalists find, but they themselves don't do the experiments, and they're not restricted by the experiments. At the end of the day, they're actually just doing math on their chalkboards, right? But I think that's consistent with what you're saying. At what point do you draw the boundary between math and physics? At the end of the day, you're just writing down an equation and looking at its mathematical consequences, right? So it's a bit arbitrary what's physical and what's not physical, and I'm very sympathetic to that.
Okay, cool. Yeah, that's exactly the view that I'm advocating, and I don't deny that there's problems with the view. I mean, I'm not like happy with the fact that, I don't want to be Max Tegmark, where it's just all a mathematical algorithm. But that's exactly where I'm coming from. There's the only, and you could deny the all by kind of going the way of Hartree-Field, for example. But the only is where you get the kind of radicalness of the empiricism. So let me give you a concrete illustration of how this plays out in Quine's case. So I told you that Quine wanted to deny, he wanted to be a fictionalist about math, but he also, was an honest broker and didn't think you could just sort of say, I don't believe in math, and then go on using math all the time, and then believing the theories that use the math. And so when he decided that, okay, I can't figure out how to do this, I can reduce the amount of math we need to assume maybe, but I can't get rid of math. Well, then his empiricism committed him to the view that you should believe in only the math that is required by science. And on any view, that's not all of set theory. So for example, even if you were to just like read off, careful regimentations of going potential grand unified theories, no one I've never heard of this, and I would be delighted to learn of a counterexample. I mean, nobody's using like objects that whose surrogates live very high in the cumulative hierarchy of sets. In other words, like here's something, for example, like it's just a completely mild assumption that's totally uniform among set theorists to assume there's an inaccessible cardinal, which is just like it's the smallest large cardinal axiom, proves the consistency of ZFC. It's just like a strong axiom of infinity, but it's very weak by contemporary set theory. I've never even heard someone gesture at the idea that might be physically needed. And so Quine put his money where his mouth was once again, and he said, so I believe in this much set theory and no more. And it committed him, for example, to the view that like the axiom of replacement is false because it has false instances, because you shouldn't believe in all instances of that replacement. So like Solomon Pfefferman have gone much further and shown that you can get by in physics with a system that Weil actually originally outlined, called Poincaré and Russell are those who introduced predicativism, but Weil then like sort of championed it for a moment before he became an intuitionist. And he was married to a philosopher. This is why I got all the ended up going down all these rabbit holes. he and Pfefferman showed that you can get by with at most quantification over the natural numbers and then constructions out of them, and maybe just the natural numbers. So the point is, if you believe in the only, if you think that if you think observation is the final check on what we should believe in, and you're going to not believe in a lot of normal things, and you're not going to accept normal methodology either. Like you just said yourself, that when you're doing physics, when most people are doing math, they're not checking with any experimentalists. They're just proving things like the Langland's program and stuff. Nobody's like checking with the physicists. Is this, I mean, they might be checking with the physicists because they might be interested in whether there's connection physics, but they're not like doubting the result if it's not applied in physics. So Quine, though, is saying that's exactly what you should do. Like, at the end of the day, you should believe in all, but only the things that figure into the best explanation of your observations. That's what empiricism is. And so the key point then is, back to our discussion of morality and mathematics, according to Harman, who was Quine's student and accepted Quine's empiricism, you have to believe in some math, maybe not all of it, but you have to believe in some math because some of it figures in. But no ethics does. So that's the disanalogy we've been waiting for. You should believe in applied math, but you shouldn't believe in any ethics. Now, this isn't the same as saying you should believe in all of standard math, or that you should believe in standard mathematical methodology and no ethics, of course. It could be a very heretical combination of positions, like Pfefferman's view of what math you should believe in, plus no ethics.
Yeah.
But that's the argument.
Yeah, I should just back up and we'll get to Harman's thesis. This Quinean empiricism, it sounds like this is a moving frontier, right? Because as we discover new physics, new scientific laws, we might need more math, or maybe we might even prune some math conceivably if we find something simpler. So this seems to be there's the question of what is and what we know, but it's certainly at the level of what we know. This is kind of a moving criteria.
Exactly right. At the level of what we know. So this is a theory of justification. Justification is not the same thing as truth.
Right, that's right. Right. Yes. That's right.
So yeah, it's a claim about what we should believe in.
That's right. Right. Okay.
And exactly right. I mean, that's going to be, just to be fair, that's going to be a consequence of any reasonable epistemology, though, right? Like what you should believe in depends on how much evidence you have and what your
Yeah. Fair enough. Okay, and then back to Harman's thesis. Maybe actually you can ground it in an example and sort of just looking around. I think a very typical example of an instantiation of Harman's thesis in say why maybe morals don't exist is because they aren't needed for explanation, right? So for example, you might say, okay, why did Bob kill Alice? You might say, well, because Bob's an evil person, but actually evil doesn't do any work if you unpack that, because Bob is a person who's frustrated and he can't feed himself, and so his hunger led him to kill Alice to take her credit card and go buy himself a meal, right? Those are all physical explanations, right?
Yeah,
I mean that's the argument, right?
Yeah, the argument is that on the one hand, we have no idea how to do science without math, but on the other hand, it seems like you can explain everything without reference to moral facts, alleged moral facts. Right. So he's particularly focused on what he calls observations, but this is a Quinean idea again, and it doesn't correspond exactly to what you think of. So he's specifically focused on what's the explanation of your spontaneous judgment that, say, like, he uses an example of some kid gasoline on a cat, and we just spontaneously judge, like, that's messed up, and he asked, why did you come to believe that? Now that question is ambiguous. Like, you could ask for our reasons for believing, and we would have reasons, like, because you shouldn't cause needless suffering and so on and so forth. But that's not what he's asking about. He's asking, what's the causal explanation for your coming to believe it? And that'll be something about, as you say, like, the cat deflecting photons, hitting our retinas, stimulating our optic nerve, blah, blah, blah. But by contrast, if you ask a question like, again, like, why did the screen exhibit a streak outside the bubble chamber? Well, you'll refer to the particle that it's representing, but you'll also just use a bunch of math. Now, this is exactly where, somebody might say, yeah, but the math is playing a different role. But I agree with you. When you get down to, when you get down into fundamentals like what's an electron and stuff, it's going to be a bunch of math. So I'm with you on that. Now, the response to Harman, there's two responses that I think are relevant to why this maybe isn't a great argument. So the first response is that observation is itself a very delicate idea. And if we mean by it what Harman means by it, namely a spontaneous judgment without any conscious inference, then notice that we're able to observe all sorts of things which could include ethical facts. So let me give you an example. So there was a whole debate in the turn of the 20th century over what are called protocol sentences. And this is the issue is that if you're an empiricist and you think something like Quine believes, you've got to have a definition of observation. But this turns out to be an enormously vexed issue because anything that's going to justify you needs to have propositional content. It needs to be the kind of thing you can write as a sentence because only those kinds of things can imply anything. So your observation in the sense of what's justifying your belief needs to be something you could write down. So what did you observe? And then you could write it. Well, any observation statement, a report of an observation, is going to be couched in language which carries with it commitments which are in principle doubtful. So for example, let me give you the most concrete example of an observation that seems to be beyond serious question. I observe a table in front of me. Okay, if there's anything that you can just observe, I can observe tables. Well, but that's a theoretical conjecture that could be false. The simplest case would be I could be dreaming, I could be a brain in a vat, I could be hallucinating. But set that aside. There's also just views in metaphysics according to which there's no composite objects. There's no things like tables. There's just field excitations arranged table-wise, so to speak. So even my observation of a table is a empirically loaded conjecture that's the combination of a physical stimulation and an ontology, a view about what exists, and then I spontaneously judge table. Well, okay, but if that's what counts as an observation, then why can't I observe the badness of what the kids just did in the relevant sense? Now Harman promptly adds, yeah, but as you say, the fact of the wrongness is not playing a role in why you made that spontaneous judgment. But unless observation is going to be something that I don't even know if I'm having one until I know what the right explanation of everything is, it can't be the case that whether I observe something depends on what the true explanation of it is. It could be that my belief gets undermined by knowledge that I don't need to assume its truth and its explanation. That's what chapter 4 is all about. But the initial, I observe a table. I'm justified in believing there's a table in front of me until somebody gives me reason to doubt, to think otherwise. And whether or not what's called mereological denialism, the view that there are no composite objects, is true, I don't need to know that before I can observe the table. Again, the observation could be mistaken.
Yeah,
that's just light.
Is this another way of maybe getting to the point of maybe where you're going, which is that sort of what the way an observation is constructed out of simpler observations or facts depends on kind of what your atoms are. And if your atoms are things that don't have any moral attributes, instead of evil, and it's whether you're hungry and things like that, then by definition you don't need any moral explanations, because in your framework these moral things are composed out of let's say physical atoms. But is the point you're trying to make that maybe there, if you had a different way of thinking about things, there could be things where actually good and bad or other moral languages are your kind of atoms, or things that can't be reduced to these physical things that Harman's saying that is sufficient? Is that kind of maybe the point you're trying to get at?
Yes, so long as by atoms you mean observational atoms, right?
Yeah, that's what I meant. Yeah, that's right.
Yeah, the technical term that is relevant here is called supervenience. So some properties supervene on some others when you can't vary the distribution of these without varying the distribution of the others. So for example, most people think the chemical supervenes on the physical, and most people think the biological supervenes on the chemical. That is, you can't vary the facts about molecules without varying physical facts. The facts about molecules are fixed by the physical facts. Okay. That's the same with ethics too. So whatever ethical facts are, you can't have two situations that are totally identical in all physical respects, but one is good and the other is bad. I mean, whatever is built into our notion of good and bad, it's a function of kind of what the person did, or what action or event transpired. So the point is, this is the key point, all our observations are of supervenient properties. That's why things like charm quarks are postulates, because we don't observe the ontologically fundamental ingredients of reality. We observe things like computer screens. And the point is that if that's what an observation is, then there's no obvious reason to think that we can't have moral observations. And Harman's objection to this idea about explanation seems like it's actually kind of putting the cart before the horse, because you have to distinguish what you're justified in believing versus what evidence could undermine that justification. And chapter 4 is all about whether or not Harman's claim, if true, would undermine the observational evidence. It argues that it doesn't, but either way, nobody can claim that you're not justified in believing there's a table in front of you if mereological nihilism happens to be true, unbeknownst to you.
Okay, sorry.
Because you would never get.
Okay. Yeah. I think you're making a different argument than I thought you were going. I think. Let me just talk it out. So you're saying that, okay, well, actually, as a matter of fact, at least with our ordinary eyes, we only observe things like tables and computer screens. We don't observe with their eyes, to be very simple, atoms and things like that. Those are kind of, for lack of a better phrase, kind of mathematical or abstract constructs. And since we do regard tables and computer screens as real, even though they're composed of these atoms that we don't directly observe, then it's not a refutation to say that, oh, morals aren't real just because they're decomposed into these other atoms, for the same reason that we accept tables are real. So is that kind of the argument you were trying to make?
Kind of. Here's the way to think about it. So think empiricism is the view that we're justified in believing all and only those claims that the best explanation of our observations. Okay, let's take the computer screen case. Right. So I see a bunch of readings on a computer screen. I now apply empiricism. I should believe in all and only what figures in the best explanation of those observations. Suppose that, and that will include reference, let's suppose, to electrons and bosons and whatever. Okay, the point is that I had to take the observation, which is of a computer screen, as given, as prima facie justified, in order to get going with that. I'm never going to get to atoms and molecules if I can't start with computer screens. But of course, it could be that it's only, say, atoms and molecules. And at the end of the day, I'm going to sort of throw away the latter and not believe in things like computer screens. I'm just going to believe in atoms and molecules composed in a certain way. But if that's the case, exactly the same thing may be true in the moral case. The data that I need to explain might start out with something like, what those kids just did is wrong. Now, what's the best explanation of that? So that's the, I don't want to.
Yeah, I see what you're saying. Yeah, that's right. That's right. I think, there's this kind of, kind of like, it's sort of related, I think, to like views of emergence, right? There are different levels of description, and even though higher levels can be reduced to lower levels, it's still useful to have this higher level. And I think you're saying something analogous to morality, like, evil or wrong or good are higher level things. You could reduce it to psychology and atoms, but it's still useful to think about them, and therefore it is compatible with this Quinean criterion because it is a useful explanation.
Well, I think that is actually the second point. So the point I was just making is that observation itself is already loaded in high-level descriptive properties. Right. So it can't be that sort of I have to first know what the best explanation of seeing a table is in order to infer to its best explanation. I get to be justified in believing there's a table in front of me just because it looks like.
Yes.
I would
never
get.
Yeah. Observation is already happening at this higher level. So right,
exactly.
That's the point. That's right.
Yes. Yeah, that's right.
Yeah.
But the second point is indeed what you're just saying, which is that it's not at all clear on inspection. Now, I'm not advocating this view, but I'm just clarifying that actually moral explanations are always illimitable. So notice, first of all, that a lot of stuff gets explained at the high level, right? So, we work with cartoons often in philosophy, talking as though at the end of the day, everything's just explained by physics. Try explaining anything of interest around you just in terms of the standard model. That's going to be a huge pain. So in reality, you make use of evolution, you make use of sociology, you make use of economics, you make use of history, blah, 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 blah. And the kind of naturalist position that Quine is advocating is you should believe in all that stuff, because all that stuff is part of the best overall. So Quine, he thinks of history as a natural science. Like he's using natural science in a very broad sense. He thinks of philosophy as natural science. All of this is just part of the overall project of making sense of the world. And there's idiosyncrasies of the different sub areas, but any such area is if it figures in the best overall explanation, then believe in its postulates. And one view is that, if you really think of ethics right, ethics is just kind of like a very high level of empirical science at a relatively primitive stage. It's like a very high level generalization about like what contributes to human flourishing. And people like Derek Parfit think that, religious dogma really set it back a long time. I mean, as he often puts it, it's only a relatively recent event to have such a thing as secular ethic, the way we have secular science. It used to have to always be, and make sure you get the right answer, So it's not shocking from somebody like Parfit's point of view that ethics would seem to be in a kind of infant stage, given its connection to theology, and given that it's a very recent event that we've even had departments where you're allowed to think about what you ought to do independent of any. I mean, like even back when Russell was at Cambridge, I mean, he was still, he was kicked out for protesting World War I and stuff. I mean, it's a recent event to be able to just think freely about ethics. So on this high level empirical science view, the thought is that no, these generalizations that you get with words like goodness, or maybe it's better to think about what are called thick ethical terms that both involve a descriptive and an evaluative component, like courageous or just or unequal, things like this. You get explanations of empirical phenomena, that is, phenomena where we're not dealing with the first issue that they're already couched in moral terms. We're saying this phenomena is stuff that we can describe non-morally. But like Nicholas Sturgeon pointed out, like, there's a question, apparently this is, I don't know, I'm taking Sturgeon's word for this, but apparently there was a debate about, given that slavery is such an ancient institution. I mean, it's not like slavery is anything new. It's been around since before writing. Why did abolitionism arise only as a concerted movement like the 19th century? And apparently, I have no idea whether this is true, but apparently a prominent argument is that because chattel slavery, the kind that was dominant at that time, was especially bad. I mean, it was especially egregious and inhumane. But the point is, bad, egregious, inhumane, all those are negative terms. And if you try to say exactly the same thing without any reference to evaluative ideas, according to Sturgeon, you're going to end up with a much worse explanation. It's going to be really gerrymandered and like long and ugly, just like it would be if you tried to explain a biological fact using only chemical facts. So the second reason then to be skeptical that Harman's contrast between math and ethics gives you reason to believe in math but not ethics is that it's not actually clear that he's right, that ethics doesn't figure into the best explanation of our observations. It's sort of like you're comparing this ancient and established enterprise that's been allowed to sort of, do its own thing independent of any theological concerns, to this, this really recent secular ethics is a recent thing. And in fact, it's still so recent that often when I just, I'm sitting next to somebody on a plane or something, they ask me what I do and I try to avoid the question, but if we really into it and I have to say something about like, what do I teach? I teach ethics. The idea that you can even have ethical truths that aren't somehow just, the result of God is puzzling to people. They're so used to that thought. So the big picture is that I find Harman's contrast wanting, both because at least you want to be a mathematical realist in any recognizable sense and believe in the math we actually use rather than just some tiny little fragment of it. Um, and uh, and if you want to be a mathematical realist in anything but the like kind of the letter, if you want to be it in the spirit, it's not clear that Harman's argument it's very clear that Harman's argument won't get you that. And secondly, it's not clear that we can't justify ethics in actually something broadly like the way that Harman wants to justify, even though they look so different on their face.
I see. Okay, great. Yeah, that makes a lot of sense. I think in the interest of moving forward, why don't we maybe we should move on because we went quite deep in this chapter 3. But great, I think that made a lot of sense. We do have two things left. I guess we have this. We said I guess we were going to maybe skip chapter 4 in the interest of time. This reliability challenge of chapter 5, I think, is interesting. I think that's definitely overlooked. I think mathematicians being kind of, let's say, Platonist and thinking math is real, we never kind of have to think about how do we know math, just because I guess for mathematicians it's sort of self-reflection, or it's obvious. Kind of a dangerous word to write in a proof, but it's sort of obvious. If you write a good proof, it's clearly true, and you don't have to worry about how you come to have reliable knowledge of mathematics, right? So I don't know, maybe you want to say a few words about the reliability challenge, what it is, and its implications for mathematics and morality.
I'll be quick with this, which is just the key is to realize that even if you answer the question of what justifies our beliefs, in other words, why is it reasonable to trust our judgments in ethics or math? And we just consider two ways to think about that. One is like kind of, as you say, reflection. Like, why do I believe the axiom of extensionality? Because when I think about it, it just seems obvious. That says if two sets have the same members, then it's the same. Or maybe it's the role of the subject in empirical science. Okay, but this is about justification, and it's very natural to think that kind of once you've answered that, you've answered the problem of knowledge. But knowledge is famously consists of more than justification. It's justified true belief, probably plus something else. This is a famous problem called the Getty error problem. But the key point is it's true belief. It's belief that you only know something if you got it right, not just if you're being reasonable. You can reason in lots of situations where you have false beliefs because you've got bad evidence. Like if you're a brain in a vat, sadly, you aren't, Tim, but if you're a brain in a vat, you should still think you're talking to somebody. You have all the same evidence that you would if you were, I mean, if somebody's pulling an elaborate conspiracy on you and made it look like, a deer went through your yard by planting tracks in your yard, you should believe a deer went through your yard, but you'll have a false belief, so you won't know it. Okay, so the trick is, how do you explain the truth, or more generally, reliability of your belief in, say, the theorems of Peano arithmetic and so forth? That's the hard one. The easy one, relatively speaking, is the justification. But we want to know why are your beliefs, your intuitions, your judgments about, say, the axioms, why are those reliable symptoms of the facts? Mm-hmm. And this is exactly where evolution comes in, because it's very common for people to say that there's a difference between math and ethics in this regard. In both cases, there might be some evolutionary explanation of our coming to have the beliefs we have. But in the mathematical case, that explanation shows that it would have been advantageous for us to get the facts right, rather than just to have the mathematical beliefs we do have, whether they're right or not. Whereas in the moral case, the thought would be, I'll come back to this in a second, because I know that's kind of, I'll explain exactly by that. In the moral case, the thought is like, to explain why we have the moral beliefs we have in terms of evolution, you don't have to assume that it would have benefited our ancestors to like get the moral truth right. It just would have benefited our ancestors to do things that pass on their genes. And that happens to be the following things, whether it's right or not. So let me now try to be precise about what I just said. So the tricky thing about that argument is that you have to distinguish two concepts. One concept is being selected to have beliefs with property F, which are in fact true, from the concept of being selected to have true beliefs, the true F beliefs per se. So the key here is, how do you test this? You test in terms of a counterfactual. So how do you test whether you're immediately selected to have beliefs with some property which actually are true versus being selected to have true? In other words, is it like, here's the rough way of putting it, but this is very risky. Is the reason you believe that, say, 2 + 2 is 4, the reason that was evolutionarily advantageous because 2 + 2 is 4, or is it for some other reason? Similarly, is the reason that you believe that, killing your offspring is wrong, the reason that was evolutionarily advantageous because it really is wrong, or something else? That's the intuitive difference. But to make it clear, that is to cash out the idea, the reason that what you have to look at is counterfactual. So here's the claim that needs to be true. Let's just think about arithmetic. Actually, let me use a concrete example rather than talk so abstractly. So what we're asking is, in order to check whether the second case holds, that's the important one. That's the one that's going to explain reliability, rather than just the first one is consistent. This is consistent with it just being a fluke that we got it right. We're trying to figure out why it's not a fluke.
So this counterfactual is in the first
No, this is if we were selected. True, yeah.
Okay.
If you were supposed to have true arithmetic beliefs per se, then, for example, had it not been the case that 2 + 2 is 4, it wouldn't have benefited our ancestors to believe 2 + 2 is 4. Whereas if we were merely selected to have the arithmetic we do have, which happened to be true, then had 2 + 2 not been 4, it well have benefited our ancestors still to believe that 2 + 2 is 4. Because the explanation for its advantageousness is something else. The only reason I'm using that is because there's no plausibility to the thought that our ancestors believed things like, the axioms of real analysis. So we have to use really rudimentary cases. But suppose that 2 + 2 didn't equal 4. And if that sounds impossible to understand, it's just the claim that suppose the 2 didn't bear the plus relation to itself into 4. That is, that's a first order consistent statement that 2 + 2 doesn't equal 4. That has a model. So suppose that were the case.
Oh, in the sense that plus is just another binary operation that just doesn't mean what you think it is. Okay, right. I think that's
that's a loaded way to put it, but yes, that's exactly right. That's exactly right. It's just So suppose 2 + 2 didn't equal 4. What would it have benefited our ancestors to believe? If it would have benefited our ancestors to have a correspondingly different belief that 2 + 2 didn't equal 4, that shows that what's doing the work is the truth of the belief. That's why it benefited our ancestors to believe that 2 + 2 is 4. But if we vary the truth, and it still would have benefited our ancestors to have the same belief, then truth isn't doing the work.
I see now. Okay. So in this case, F in your first column is 2 + 2 equals 4.
Well, it's mathematics.
That's right. Yeah, in this example, 2 + 2 equals 4 is this F that you're saying, and there's a distinction between we believe 2 + 2 equals 4, and it by a fluke, as you wrote, that it's actually true, versus that we believe it because it by virtue of it being true, which binds us to the fact that were it not true, for example, then that we would have that corresponding belief, right? Yeah,
that's exactly right.
Okay, yeah, I got it now. Yeah, okay.
So the point is, you can argue that that second thing is not the case of arithmetic, and the way to do it, here's the argument. Had 2 not borne the plus relation to itself and to 4, it still would have been the case that if there's a line over there and a line over there, let's make 1 + 1 equals 2. Had 1 not borne the plus relation to itself and to 2, so had 1 + 1 equals 2 been false, it still would have been the case that if there's a line over there and a line over here, and the line over there is identical to a line over here, then there are exactly 2 lines over there or over here, where this is just a logical truth and doesn't actually make any reference to numbers. So in other words, The reason it's useful to believe that 1 plus 1 equals 2 is actually logic, pure logic. This won't work in general. If it were useful to believe the axioms of real analysis evolutionarily, we couldn't make this argument, but it wasn't. So the point is, like, where is it plausible that we were selected to have mathematical beliefs? It's plausible like basic arithmetic geometry. But in those cases, you can give a perfectly non-mathematical explanation for why it was beneficial to have the beliefs that we do have. So it's just like ethics. In other words, the evolutionary explanation you're coming to believe that 2 plus 2 equals 4 is not like vindicating of 2 plus 2 is 4.
I see what you're saying. I see.
To use the lingo, it's debunking, some people would say.
Okay, I think I see what you're saying. So you're saying that if you're saying that evolutionarily, let's say, no, we're trying to understand right now why our beliefs are justified.
No, why they're reliable.
Reliable, right? And you could try to make an evolutionary argument by saying, the fact that our beliefs are reliable are evolutionarily advantageous. But the problem with that argument is that had truths been different, we would have had different beliefs, and therefore that's not an argument for the truthness of those beliefs to begin with. Is that right?
No, had the truths been so the issue is, so people kind of flippant argument that I think doesn't withstand scrutiny. And the argument is, in the mathematical case, at least with arithmetic, there's an obvious explanation for why we'd be reliable. It would have been really unwise to have false arithmetic beliefs.
Right.
But that is ambiguous between these two things, having beliefs with some property, which are actually true, and having true arithmetic beliefs per se. Only the second argument, or only an argument for the second thesis, would show that our arithmetic beliefs aren't a fluke, that evolution explains their reliability.
I see.
In order to check whether that's the case, we have to vary the arithmetic truths and ask what it would have benefited our ancestors to believe in the different case arithmetically. And you can argue that it would have benefited our ancestors to believe exactly the same thing arithmetically. The logical truths would have been the same, and the logical truths are doing work. So in other words, what explains the usefulness of believing plus 1 equals 2 evolutionarily? A logical truth about what situation you're in, not that 1 plus 1 is 2. This is an argument that the situation between the ethics and math is the same.
Okay.
In other words, it's very natural to think there's an evolutionary explanation of our reliability, at least with respect to basic arithmetic, but not in ethics. Because in ethics, one issue is the truth, and the other issue is why it benefited us to have the moral beliefs that we have. And the truth per se wouldn't have been beneficial to know. It's just, and my claim is, the argument is that these cases are actually totally analogous. But in neither case is the truth per se doing the explaining. If for those who want the gory details, I talk about it in the book, but also in a paper called Morality.
I see. Sorry. So I think this was actually chapter 4. Is this
this is chapter 5. Chapter 4 is about the relevance of explanatory indispensability. So quite generally, does it matter whether the fact that killing is wrong figures into the best explanation of your belief that killing is wrong? And that could be an evolution explanation.
So why don't we? I guess now we have time for the last part, which is this pluralism business. Is that right?
Yeah. So the conclusion of this 5th chapter is that
or sixth chapter, right? The last.
No, the 5th chapter.
Sorry.
The 6th chapter, is that the problem of reliability, explaining reliability, is equally present in the mathematical and moral cases. There's not actually, when you go through all the apparent differences, they don't stand up to scrutiny. And evolution is just the most obvious, but that's just one. Unless you adopt a particular conception of math, which is actually pretty wild, and it's not for sure that it even makes sense at the end of the day. But the conception is that basically it's all like linear geometry. And what I mean by this, there's no final arbiter in math, no once and for all meta theory in which to carry out all the constructions or to check consistency or anything like that. Different meta theories are just like different geometric spaces. And so this is a kind of, the word I use for it is pluralism, but it's kind of like the relativism were true. But it's not literally radical relativism, because it's not the claim that, typical set theory statements are shorthand for according to this framework. That's just you're literally hopping into different meta theories, just like you do in the geometry case. It's not like, in the geometric case, like all the spaces, if you're a Platonist, are as real as the others. It's not like one of them is really real, the others aren't. There's just lots of spaces, Similarly, one could hold the view, and this was originally put forth by Mark Bolliger, that the different meta-theoretic standpoints, the kind of ultimate court of appeals for questions about like what functions there are and what subsets there are and what principles you're allowed to use in proving theorems in any other field. Maybe those are also like different geometric spaces, and they're kind of all there equally real. So the reason this view would change the dialectic is because the idea would be that whatever axioms we arrived at, we would have been right so long as they were consistent. They just would have been true of this meta theory rather than that meta theory. Now, again, there's some good old stuff that I'm ignoring. You have to refine it a bit. But the idea is there's availability for that kind of view, which I'll call realist pluralism. The mathematical reality is totally real, but it's a very plentiful place. There's kind of like enough mind and language independent truth to go around so that whatever meta theory you want, the world cooperates. Okay.
Yeah. Kind of like a mathematical multiverse, I think. Is that due to Joel Hampkins?
Right. So Joel Hampkins uses that term, but it's all the same view. So Mark Bolliger, I think, called it plenitudinous Platonism in his 1995 paper, and then Zolta and Linsky, and around the same time, proposed this, and they called it naturalized Platonism. Hartree-Field and Penelope Matty call it plentiful Platonism, and then Dickens calls it the multiverse, but it's all the same idea. It's the same idea, and the reason it's not totally beyond question that the view is actually coherent at the end of the day is because when you try to formulate it, you invariably fail. So if what I just said, like if I say something like every consistent set of axioms has a model, well, that's there's nothing incoherent about that, but that's just a reality. That's just the completeness theorem. And the point is that statement, the models you're getting are set models, which are not the intended models of, say, ZFC, because ZFC's intended models are process. So there's an issue about ineffability here, which is that like any meta theory takes itself to be everything. It takes itself to be maximal. So you're going to state this theory from the position of some meta theory, and it's going to come up short if it's saying it's going to come up short if it's saying something coherent. And what want to say is something you haven't said, because it's going to take itself to be maximal, even though it's just one among many meta theories. So there's an issue about whether the view ultimately at the end of the day is coherent. This has been debated since the 90s. But if it is, it seems to afford account of our reliability that's consistent with realism, with the mind and language independent truth of math. Math is like a very plentiful place. And the reason we're reliable is because kind of no matter what axioms the contingent facts of history led us to, they would have truly described some part of it. So the problem is that obviously is not a satisfying view in the moral case. Like you could hold that there's a moral multiverse. In fact, in a sense, as you pointed out at the beginning of this interview, there's kind of trivially a moral multiverse. Like, there's utilitarian ethics, there's deontological ethics, there's virtue ethics. I mean, who could deny it? So in a sense, like, sure, there's lots of different frameworks in which to assess ethical questions, but ethics, unlike math needs to ultimately issue in a single directive. You appeal to ethics or any way evaluative reasoning to figure out what to do. Can't be like, well, I ought utilitarian to kill the one to save the five, and I ought not deontological, and that's all there is to it. Just like the parallel postulates, true in Euclidean space, false in hyperbolic space, or something. You need, okay, now which framework to use? So, but if I say which framework ought I use, different frameworks are going to tell me to use different frameworks. So at the end of the day, what you get is this non-factual question. It can't be a factual question. It can't be put into one of these frameworks, which is, for lack of a better way to put it, it's the question of what to do, not what ought I do. So it's like the question of which framework to use rather than the question of which framework I ought to use. The conclusion of the book is that the non-cognitivists were right about that question. Remember, the non-cognitivists were the people who said moral statements are not the kinds of things that can be true or false. The conclusion of this chapter is that the question of what to do, the final question before action, the question you're deliberating over when you ask which framework to use or which notion of ought to use, that can't be the factual question of what framework you ought to use, because that'll just give you either a triviality or a regress. So you Kantian ought to use Kantian ought, you utilitarian, okay, yeah. Now, whether I want to say really, but that's just another ought, like really ought is just be witnessed by some ought, just kind of like any given notion of set is just witnessed in some universe of sets. So this need for uniqueness and this need for action distinguishes the ethical case from the set theoretic one, where it seems like only potential way to resolve deliberation requires some non-factualism or non-cognitivism about the question we're asking, in a way that you don't have to have that kind of view about math. You can be a realist pluralist about math. But in the ethical case, at least when it comes to the final question before action, you've got to be an anti-realist. There's no, because the way to put it is, that doesn't involve any pluralism, is to think about a quote from Nietzsche, though he wasn't actually making this argument, but Nietzsche's always a good person to name drop. So Nietzsche has this line, I can always evaluate the value of these values. And a way to think about the point as applied here is like, for any concept of ought, or any property I might latch onto, it's always an intelligible question whether to care about that, whether to promote it, whether to think that's the thing to do. And the mere fact that it's called good does not settle the question. It could be that we inherited a concept of good or latched onto a property that was not actually the thing to latch onto, so to speak. This was exactly the worry Nietzsche had, that moral terms were introduced by a certain class of people to basically keep another class oppressed. So the point is, it's an intelligible question. Sorry, go ahead.
Yeah. So I think just to make this very concrete and simple, sort of, what you're saying is that, okay, in the moral multiverse, there are many different value systems. At the end of the day, you only get to make one action, and how do you do that? And I think you said a few things. I think the thing you said at the very end was you have to be a moral anti-realist, and is that because if you were a realist, maybe you would have an answer, or there would be a clear-cut answer and that somehow doesn't follow from the fact that you have all these competing theories. I wasn't really clear what you meant by you have to be an anti-realist there.
The claim that you have to be an anti-realist about the question of which framework to use.
Okay, I see.
If you're a realist, if that were just another fact, okay, well, that's, depending on which one you look at, you'll get different prescriptions.
Okay, so then actually, I guess maybe the real the most pressing question is sort of, okay, so then if you're an anti-realist about of there being a definitive answer about what to do, what do you how do you actually end up deciding what to do? Right?
I just,
Yeah.
first of all, just want to clarify exactly what is, maybe here's the most useful way to think about the problem. Given that you have all these different frameworks uncontroversially for ethics, and they each would just stipulate they correspond to different properties. So there's the property of utilitarian goodness, there's the property of deontological goodness, the property of Aristotelian goodness, blah, 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 blah. And of course, then you just use the word ought and good, and there's a question of natural language semantics of which property we're picking out. But hey, that's just another property. Now, here's what could it mean to say that one of those theories is really right? It's not something about mind and language independent truth, because they can all be mind and language independently true. There's enough. It's just like the math case. There's enough mind and language independent facts to go around. So what we want to say something is, we want to say something like, well, yeah, but this notion of goodness is the real notion or the right notion, or but what does that mean if not just something about what we mean by the word good, which itself can always be evaluated? Maybe we mean the wrong thing, so to speak. I say so to speak because wrong is an evaluative term. Maybe don't use wrong, use wrong star. you know? So
in the math case, right? It's kind of like goes down to taste, I guess. Like, oh, do you prefer this axiom or that axiom? And in morality, what's the analog, I guess, of taste?
Well, right. So just to be clear about the like tying this up though, so the claim is that before action you have to decide on a framework, and that decision can't be a question of what you ought to do factually construed. That doesn't settle deliberation, because now there's the question of whether to consult ought rather than ought star for some alternative. So okay, so but then your question is, okay, but how do you decide non-factual questions of what to do? How do you make decisions, given that the way to do it isn't by consulting the moral facts? And here is the rough answer, I think, but I mean, I think this is a very deep and hard question. So there's two steps. The first step is you got to figure out what your fundamental values are, and by values I mean like your judgments about what to do of the most basic kinds, like pursue pleasure, avoid pain, something like this. And this is it's not a cognitive question in the sense of asking about the distribution of any facts. It's a question of action. Like it's an immediate question of action, what to value. The most sophisticated models of this kind of thinking, just in case it's all getting way too abstract, is Simon Blackburn and Alan Gibbard both have books developing a conception of decision making that are exactly modeled on the idea that this can't be a factual question. Their reasons are different for thinking so, but it's a model of this. Okay, but once you've got that, then you can decide on an instruction manual, which is one of these ethical frameworks, and then you can follow the instruction manual. So like it's not like in day-to-day life we have to, from a vacuum, decide what to do. No, we rely on an ethical framework that we've more or less consciously adopted. Just like a realist says that that's the one true framework, the issue is, the disagreement is over what it means to say that's the one true framework. And the claim is that the only comment you can give to that is not a factual content, like it's the right framework, capital R. I mean, what does that mean? I'm open to suggestions, but what does it mean if not just something about how we use words, but rather use that framework? In other words, it means just something about our endorsement of the framework. It's something about us. It's a decision on our part to endorse that framework. The idea that it's really right, if you try to give any factual content to that, you'll just be in the same place we were before. Okay, so why care about what's right as opposed to right star?
So I mean, just to summarize, I think I perceive you're probably saying something that's very intuitive and kind of the natural answer that you would have, at least I would have given before having this conversation, which is sort of at the end of the day, we make choices, whether it's our axiom system, what morals we choose, how we vote, based on our values, our preferences, right? And whether they're aesthetic, whether they're self-serving, whether they're good for society, right? Maybe your point is that those are sort of, that's outside the scope of at least the word ought and maybe the word real or anti-real, or I'm not well versed in these words enough to say what, but it sounds like there's like a secret secret sauce that's missing, or underdetermination that is sort of not within the scope of these typical debates. Is that sort of like the point you're trying to make?
Roughly. So the way I would put it in those terms is the question of which values to have cannot be a question of fact. So
okay.
you can evaluate your own values. As you say, you have preferences and stuff, but it's not like I mean, one of the interesting things about moral reasoning is we can criticize our own desires, right? So it's not like we just find ourselves with desires and leave it at that and then just do it. Sometimes we say, I have a desire to do this and it's the wrong thing to do, so I'm going to try not to. We might be weak in will anyway. Right. But the point is, we can always step outside of our how we find ourselves and evaluate the values that we have. But the claim is that evaluation, that's not a claim of fact. It's not just that it doesn't happen to be, it can't be. There's no content you can give to the idea that I have the wrong values, capital W. You can, of course, have the wrong values according to some value scheme and be talking about that and say something true, but that's not the kind of thing that will resolve deliberation about what values to have.
Okay. I think I say this has gotten pretty abstract. I mean, I understand what you're saying, but I feel like there's so many probably things to follow up on this that might this might I don't know if this might be a good place to end, or if there's any final thoughts on that. Yeah, because I feel like we're now at the point of like, okay, I'm thinking of all these tangents in my head, but I don't think we have the time to discuss them. For example, things like, okay, so like I don't know, like even things like, okay, what about free will? What about the multiverse, where now maybe potentially you're actually doing every possible action, and what does it mean to be you and all these words? I don't know. I'm just, my mind is going off in all these directions, but I don't think we have probably time for that. I don't know if you have any quick thoughts on that. I don't want to go down that rabbit hole, but yeah.
So I don't have any quick thoughts on free will, or if the multiverse view is true, or what ethically, how do you and so forth. But I can just sort of tie things up by saying, so
let's summarize kind of the takeaway now and the things we discussed. Yeah.
Morality in mathematics, it's that we should be realist pluralists about math, and necessarily anti-pluralist, or what I call objectivist anti-realists about the final question in deliberation before action, which is often thought to be an ethical question. But what I'm saying is it can't be an ethical question if that's construed factually. So the idea is, like, by comparing ethics and math, there's so much similarity, contrary to what it might seem, but the views you ultimately get force us to distinguish two concepts which have often been identified without sort of thinking: the idea of an independent reality, realism, and the idea of objectivity, or only one answer to a question. And the idea is that you can have realism and a radical faith of objectivity. That's the situation in geometry if you're a Platonist about mathematics. Like, it's not up to us, the different facts about the different geometries, but kind of like it's almost as if it were, because whatever answer I can find you a geometry suit. By contrast, ethics it's as if the most radical relativism were true. There's like one true answer you got to arrive at in order to act. You can't sort of live with a plurality in deliberation. You have to take a stand. But the only way that can be true is if ethics is not a factual discipline, if realism about ethics is false. So the conclusion is supposed to be kind of puzzling, because you started out with this thought of like, okay, realism, are there independent facts about math, and are there independent facts about ethics? Can you be a mathematical realist and a moral anti-realist, blah, blah, blah. And you end up with this idea of, yeah, there are independent facts about math, but it's as though there weren't. And no, there aren't independent facts about ethics, roughly speaking, understood as what to do, but it's as though there were. In the sense, our original conception of independent facts, things like, because we think of facts as kind of unique to do in the physical world. Like in the physical world, there's There's a single fact that E is E squared. It's not like you can have it however you want, unless certain multiverse scenarios that I won't be considering are true. Yeah.
Okay, great. This was a lot to digest. I'm certainly going to have to think more about these issues, but it was very fascinating to discuss them with you, Justin. And thank you so much for your time.
Thanks so much for having me, Tim. And yeah, I look forward to further conversations.
Thank you.